Hi everyone, thank you so much for coming. Python lecture number 2, I think. So last week we introduced you to Python, and I forgot to pass the sign-in sheet. I could do it in a break. Your homework was last week is to go over the compilers. Okay, I think I suggested to you 3 or 4. And the previous class by Charm and Visual Studio from Microsoft, and the kernel comes with Python and I think another one. I think they are all good. All you have to do get used to one of them, okay, and get used to it because you're gonna write a lot of code. Number 2, as I said last week, in this course I will start from the very basics. So the first few lectures will be very simple, very easy, especially for those that programmed before. We'll start from the very simple statements to the loops, and so on and so forth will go up. So the first half of the class will cover all the basic components of Python. That includes object-oriented programming. Okay. Then after that, we're gonna move to data science. So we're gonna learn about the different modules, okay, like such as pandas, numpy, scipy, etc., etc. All right. So you'll have homework assignment every week that you need to do. Some of you, if not very strong in programming, will find it challenging. Some of you will find it okay, some of you maybe find easy, but for all of you, the second half of the course will be very intense, and you have to learn a lot of information every week, lots of information every week. So when you start going over these modules, all right? So please work very hard to learn Python by yourself. After each lecture we have in here, going over examples or some examples in here that we mentioned or in the textbook that I'm using in here, it's not enough. Okay, you have to write programs. So maybe you'll find at each end of each chapter some problems or some programs to write or to modify in the chapter in a certain way. Go over them and try them out. In programming is a language. You have to speak it. Speaking a language means speaking programming language means just writing code. So the more code you write, the more you learn. Right? If you don't do that from now until we start like the tough ride, okay. You'll lose us, all right? So because we have some of you are seniors or juniors, undergrads, some of you came from different backgrounds, so I usually start like from the very beginning, okay? So, but we're gonna go very fast. Any questions for me before we start? All right? So, we started last week talking about Python, Python, it's a programming language, all right? So in here you're gonna learn the language. But also with the language you have to have the logic. You have to think like a programmer. And all of you must have this talent before come to this class. I'm sure most of you took 1 or 2 or more classes or courses related to the logic. It's very important that you know some algorithms or what is algorithms, all right? If you did not, please go over YouTube, Google, pick up a course in algorithms, watch the first few lectures, just pick up what is algorithms, what we look at when we talk about algorithms, right? So try to do that, okay. When I talk about the programming language, so for example, and when we have x, okay, equals 1, okay, you understand that x is a variable, you understand it will reserve a place in the memory and will assign a value 1 to it. Alright? This is not math, this is language. If I say x equals x plus 1 in math, this is wrong, but in programming this is a correct sentence. Okay? So I'm not going to go from here or to there. Okay, you know all of these basics, and you have to so this is not CS 101. This is not the course that you take for your as a first programming language. All right. So we'll talk today about statements, about values and data type. All right. Variables. We're gonna talk about operators, bitwise operators. I'm not sure why I have another operators in here. Expressions, order of operations, strings, comments, console input and output, block structure, and then in the second half we'll talk about the loops and the loop structure. All right. First of all, I mentioned that last week that you start your programming code with the shebang sentence. In Windows, it's not necessary. Okay, but in Unix, you should have it where it will run the env and look for the path for Python 3. Alternatively, what you could have the path for the executable here. Okay, and shebang start with the hash, then the exclamation, then the path, or you could run the environment where it can get the path for where is the program installed. Okay, this is useful if you have multiple versions of Python installed on your computer. Many people, for example, program in version 2 and version 3 or multiple versions, so it depends on where it is in the path, right? So that's a shebang, done deal. Okay, we'll come to the variables. So we know, like in any other language, a variable, you give it a name. It cannot start with a digit, okay? It could understand with underscore. It could have capitals, digits, okay? The only special character you could have in a variable name is the underscore, right? All right? And you assign a value, whatever the value for. Back in the other programming languages you had, like Java or C++, you give a type for the variable, init or float or double, right? We don't do that in Python. We don't do it in the Python. So in here, by itself, we realize that counter is integer, all right? Score, under, total, equals to 0, so another integer variable, third integer variable, all right? We'll see later the loops, okay? But as a simple code, if you're just in here, while test score not equal, okay, this number, and the statements, like the loops in Python, always the first line has end colon. You have to have that colon. Many of us forget the colon at the beginning. So while it has to end with a colon. If it has to end with a colon. For it has to end with a colon. Then the structure. You know the body. We'll talk about it in a second. Okay. So this is a simple program. All right. So all the programming languages, the first line or the first function you'll learn is how to output. So in C++, for example, we use cout, right? In here there is a very simple sentence which is print. So you have a print. Children, can you see here? Can you see here? So you have the print. Okay, print. Okay, and two parentheses. In version 2 in Python, we don't have the parentheses. Okay, that's one way to differentiate between Python 2 and Python 3 when you have a code. You don't know. So if you see the print without parentheses, then it's version 2. This is version 3, right? Okay. And then whatever you need to type inside it, separated by comma, all right? So if you need to type a text, for example, hello, you have to have a code, right? And then comma, and let's say x equals 2. Then you could print x. So the output will be hello. By default, the comma will be interpreted as space, single space, and the value of x. All right. So you could have, multiple variables, multiple texts. You have to learn how to join them and all of that. All right. What I want you also to realize. Is it easy to switch from PC to? Yeah, I think it's easy to do that. So that's easier for me. So let me go here, for example, here. As I told you, there is no language served like Python. Maybe there is, but I don't know. So let's go google.com. Right. If I need, for example, to take a look at the print, okay? And as I told you, when you program, nowadays, because programming languages are huge, a lot of functions, a lot of methods, a lot of built-in classes, right? It's impossible to have anything in your memory, literally, right? And you get confused if you learn multiple languages, so always it's good to have two screens when you work, okay, one for search. So very simple, before you need to use a function and print, for example, and Python, okay? Version 3, for example. Let's take a look, okay? You'll find many options for you. Let's pick one, right? All right. So maybe that's not the best one. Let's pick the second one in here. Okay. So it will give you examples how it works and how it's structured. I need to look at the function itself. So let's try here Python tutorial. Okay. All right. This is also. Go to the first one, that's fine. All right. So you'll see a lot of examples. Okay, a lot of examples for you. Also, you need to look at the function. I need to look at the function itself. So print as a function. Let's take a look in here. That's not what they want to show. So for something else. We say Python parameters. No format, that's fine. Format. Let's use format. So these are the, like special unit format. Anyways, so what you could have in Python, okay, so print, so you could say print, okay, whatever the values. And then you could have the separator. The separator equals what? Equals, for example, a space. That's by default. Okay? And the end equals, a new line, right? All right. So you could also change these by default. When you do print statement, it will have the end with a new line. But you could change that. All right? You could change that in the yes, here you go. That's what I want to say. So in here, so when you look at the print, it's by itself. And just that's an example. Print is a very small sentence. You don't need to learn much about it. But this is example for another 10,000 functions, how you study any function. The print, you have the objects in here. So for example, what are the objects in this in here? You have the text, you have a variable, you could have many. So the asterisk means 0 or more, and the separator by default is a space. Let's say you'd like to have the separator to be tab, just change it in here. Okay? The end of each print statement has to have a new line. Okay? You could change it in here. It could be $, for example. And print by default has to print to a file. Okay, the standard file is the screen. So sys.standard output, that's to the screen. If you need it really to print to a file, real file, you put the file in here. What's the file? And the flush is another thing, false or not. So these are, so when you look at any function, okay, you have to look at the return value. So what's the return value for a print? None, does not return anything. And at the parameters, how many parameters it could have? 4, right? So you could have a flush, by default is false. If you don't indicate it, it will substitute it for you as a false. Okay, the end, it will be a new line. If you don't put it there, by default it will be end of line. And the separator, by default, will be a space, a single space. All right? And then as many objects you could have. As many objects you could have. And the return is nothing. Does not return anything. So from now on, any function you need to study, you could go to the manual. And you have to look at what are the parameters and what is the return value. Okay, return value. Okay? So let's take another function. Can you think of another function just to study it about input? All right. Sure if this in here shows. Anyways, the same thing. I mean, here we go here. So let's take a look. For example, let's get off this one to be very hard to explain. Any other function? This is like the XYZ friend. Okay, here. Anyways, you got the idea. So any function you have to have it there. Okay, so let's fast forward. All right. So the manual has to be with you most of the time as you go, as you see in here. All right. So in here, for example, in this code, how many functions we have? How many functions? Can you tell me what's the first function you see?
Input.
There is init is a function. There is input is a function. All right. When you go to this line in here, there is no function. Then you have here, round is another function, and so on and so forth. So if you need to understand what are the parameters, what does the function do? Okay. So you need to know what does the function do, what are the input parameters, and what is the return value. When you look at, for example, here round, what do you think round does?
Rounds the number.
Rounds a number. Okay, rounds a number. What kind of number? Integer? Maybe? Float, right? Okay. So integer, what does it do in here? Cast the type to make it integer, right? Input, what does it do? Input. It reads it from the keyboard, right? Okay, so you got the idea. Okay, we could move faster now. So in here, one thing about Python is indentation. You have to indent. Okay, if you have wrong indentation, you have an error. So in here, there is extra space in here, will give you an error. Okay, you cannot have this indentation. Okay, so for example, in here you could have implicit indentation and you could have explicit. Implicit, explicit. So print text, and you can concatenate two texts by what? By plus sign, right? This is score total is a digit, is a variable, it has a value. So to be able to concatenate text, it has this to be text. So what I do, I pass it to a string function. It converts the number in here to what? To a string. So I'm concatenating string with the string, all right? And then I'm continuing, but usually I have to start from the plus, okay? the average score, then I'm converting the average score to a string. All right. This is implicit. When I add the backslash in here becomes explicit. All right. And notice the indentation. Notice the indentation. If I move the plus at the beginning of the line, it would be error. It would be compilation error. Same thing in here. All right. So we have to have indentation. The indentation, they prefer 4 spaces. Most of us like to use tabs because one it, all right? But it's your choice. The recommendation is tab. And there is implicit and explicit, okay, indentation. All right, so before I move on, just Alright, let's use this. Okay, so I could, for example, from here, and you already use this, and it's a must to learn how to use this, by the way. Okay, so for example, you could say, let me start with a file, new file, okay, and this, you have to save it first, so let's save it somewhere, okay, save as, okay, let's say test, right? Okay, so if I say x equals 5 and print, okay, print x, right? Okay, or let me say like the value of x is space close, okay, equals, and I have to close it. Okay, so run. Okay. All right. So printed the value of x equals 5, right? Okay. So let's say, for example, I need to have another print. Okay, nothing, for example, whatever. Okay, so this will be good sentence or bad sentence? It will run with error or without errors? With error, why? Because the indentation is wrong. Okay, so you have to be careful with that. All right? Okay, so it's on here. Let's run it now. Okay. There's no issues, right? Give you the results in here, right? So indentation is very important. It could give you a lot of errors. Okay, when you know the compiler will tell you. Okay, the problem is the indentation sometimes will change your logic. If it's a compilation error, right away you'll catch it. Will not compile for you. But if you have, for example, for loop and you have if statement inside it and another if statement, so the logic will change depending on your indentation. So this if statement part of the for or part of the other if or what. So the indentation is a very, it's like blocks, right? Block inside block. So you have to be careful about this. Okay, clear? All right. All right. So let's talk a little bit about the score program which we ran, I think, last time. Very important for your assignment, all assignments, okay, and for all your program to use comments. All right. comments, and explanation. Program has to be a story. All right? So you could write a code yourself tonight, and tomorrow morning you forget what you have done. All right? Because you didn't have comments, and you didn't give a proper names for the variables. Because we get easy, we need to try something, we need to just run, right? So for example, there is no need to use a variable called x. If it's, for example, for a counter, call it a counter, okay? If you have multiple counters for different reasons, give it a name. Use underscore, or you could, any format of naming you want. Okay, basically when you give a code, it has to be a full story. I need to go through the story. When I read it, so for example, I need to understand what you are doing in here, the problem statement. Then for every variable you define what does it do, what is the variable for, okay? Then for each if function you do, you have to have a doc string, we'll talk about it in a second, that explains what does it do until the end. So it will be a full story. You have to get used to this. When you go for job interviews, they'll ask you to write code nowadays. So if you are not able to write a neat and nice code that looks like a full story from A to Z, that will be a problem. That will be a problem. And it becomes a habit. If you become a nasty programmer that you write code and just run it, and you didn't get used to write a full code with a full explanation, I mean, you'll continue doing that forever. So as you see in here, you have to have, some kind of comments. It could be a full line, or it could be in the side, or it could be in a different format. Okay. Comments. I don't want to explain what comments for you. You should know it. So in here, for example, when you call a function, function, it has a function name, arguments, and the return value. And I already taught you how to check any function. Just write Python, the name of the function, you'll find like many pages talking about it, okay? Before you just try to study it, okay? And there's a lot of things that any function can do that you don't even know. I mean, when you read the manual, it will help you. Sometimes you end up doing waste work. So because you don't know the function can give you a certain functionality, you write like few lines to do that functionality, but it's just an option. It's another parameter you pass to it. So for example, if you know that print, okay, that if the print, it gives you like, for example, a space between each variable you print, right, or object you print, right, a space, single space. If you would like to have it like a new line between each variable or each object you print, okay, you could write 5 lines code, you do it. But it's very easy. All you have to do is to go and change the separator to what? A new line. If you do not know that, okay, you could do it. If print does not provide that to you, you could do it still. But you could do it also in no time if you know how it works. So it's a good habit also to check the manual. I'm trying to go in a very simple, basic things because many people, Okay, so print. Okay, so for example, print a text. Print. This is what will it print? There is no objects. But each print sentence, what ends with? A new line. So it will print for you what? A new line. Okay, and here same thing. So we'll see what. So this one printed for a new line. So understanding the structure of the function, how it works, is a very important to predict the output. All right, so we're gonna go now faster. Okay, all right. So 3 Python data types. There is a string, there is an integer, there is a float. I don't have to explain what are these, right? String is a string. Okay, this is integer. Does not have dot something. Does not have decimal value, and the floating point. The float is a floating point which has a decimal value. You have to be very careful in your programs when you're using float, because every time you run the program could give you a different result. Why? Because it depends on what is the value of the decimal part of the value, and changes from program to program, right? So we'll talk about how to fix that later. All right. All right. So how to initialize? So usually in C++, for example, you have declare the variable and initializing the value. And you could declare it while initializing it at the same line, right? For example, you could say init in C++, if you remember. You could say, for example, integer x equals 5. So you're declaring it and initializing it. Or you could say, for example, init x and then x equals to 5 and then initializing it. In here, in Python, we don't have to declare it. We don't have to declare it, okay? So, but before we use a variable, we have to initialize it. We have to give it a value, right? Otherwise, we'll take a random value from the memory. So in here, for example, first name. Do I know like this what kind it is? No. But when I assign a string to it, then this is a string value. In here, quantity 1 is a variable, but it's a wrong sentence because I did not initialize it. When I give the 3, it becomes integer, and so on and so forth. I could assign a variable to a variable. So quantity 1 is 10. Okay, quantity 1 is 10. If I assign quantity 2 to it, so whatever in quantity 2 will go to it, and so on and so forth. If the variable, if quantity 2 is not initialized, I cannot assign it to quantity 1. So I have to be careful with that. So the code literal values for a string encodes a character string, single or double, and you have integer, you have double, you have float, you have string. That's the literal values. Okay. Rules for naming, do I have to go all that? Simple, like any other programming. You could understand with underscore. So you could have, for example, I cannot write again. So you could have, for example, okay, and it's good to use your convention, okay? Myself, I hate to use shift when I write. So for example, I could, for example, say my name, okay, equals whatever. So I think that we call it camel style. So you start with lowercase and every word after that you start with a capital. That's my preference, okay? Some people, for example, like to have my underscore name, for example, equals whatever the value, all right? Whatever convention you'd like to use is fine. You could start with underscore. So for example, x value, for example. Okay, you could have underscore at the end, also at the beginning. You could have a digit, but you cannot start with a digit. So this is correct, this is correct. You cannot give a variable, for example, 7 hellos. Okay, this is wrong. Okay, you cannot start with a digit. So there's a convention. That's very easy, you could follow that and learn that. You cannot give a variable name for a key. Any new news to you here? No. So these are, keywords you cannot use. We're gonna learn about all of them as we go along. Okay. So as I said, there is 2 naming style. Okay, the camel case and the underscore rotation. It's your choice. Myself, because I'm lazy, I don't like to use shift a lot. Okay, although when you put it a capital, you need the shift, but I prefer this. I think Python preferred that one. Use whatever. Just in your one program, just use one standard. Don't confuse yourself, confuse everybody reading it. Okay, arithmetic operations. Is there any new news for you in here? Maybe this is the new one here. What is this one? Integer division. Okay. So for example, if you divide like 9 by for example 2, okay, we'll give you what? 4.5, right? But if say 9 divided by 2 will give you 4. Okay? Maybe that's the new. And what is this? Exponentiation, right? Right? Power, right? Exponentiation, right? How about this? Which? OR operation, right? So in some programming this is a power, but in here it's what? An OR operation. Just you have to be careful with this. So these are examples. I said 25 divided by 4 gave you 6. Remove the void in 25. Okay. So in here the order of precedence, like any other language, you don't have to go over that. Okay. First thing we start with exponentiation, then multiplication, division, modulo, integer division, and then after that addition, subtraction. Okay, so this is something you should know. Okay. So for example, in here, which one's gonna go first? 4 times 5, and then the addition. But in here, which one goes first? Parentheses, because of that parentheses, you know, okay, it goes. Alright, so this is a code that calculates the sales tax. So you have the subtotal, the tax percentage, which is a float. So tax amount, which is the subtotal, multiplied by the tax percentage, will give you $10 in this case. And then the grand total, what are you going to add? You're going to add the subtotal to the tax amount. The subtotal to the tax amount will give you 210. All right. Anyways, so you know what is this, right? All right. Okay. So if you need, for example, this is that counter. So if the counter is 0, you could write it in two ways. If you're going to increment or decrement, okay, counter plus 1, this is the old-fashioned. Okay, we don't use it. Most of us we don't use it. Or you have to say plus equal 1, and that's increment. And you could have also, like you could assign a value to the same way. So in here, score total, that means score total, the old value plus 70, and store it where? In the score total. Right, so you know, if you did not program for a while, this is a good refreshment for your memory, but it's a very simple stuff. Okay, same thing in here. You could do it with multiplication, you could do it with subtraction, with addition. You could do the same thing. What we call this process? Compound assignment. Compound assignments. All right. A floating point result that isn't precise. That's what I was talking about. So if you have subtotal, this amount, and then I multiplied by, okay, this amount, right? And then I multiply the subtotal by 0.1. What I was expecting? I was expecting only 275, right? Or something like that. But you see in here, okay, because that's how it's stored. And this is like if you're working in an accounting program and you know a lot of multiplication and all of that, that will every time you run the program could give you different results. So you have to fix that. So you have to convert your float number into decimal number. We'll talk about it later. And you know you have to write the program that whenever it runs, give you the same result. All right. Anyways, this is. Simple runs, how to use shell. I already talked about how to use your shell program last time. How to assign a variable, you know, a string, a variable, or whatever. It could be double quote, it could be single quote. What is the value in here? Empty string. This is an empty string. And by the way, it's very important, you know, because sometimes when you're in your code, you have to start with the empty string and move forward, right? There is the string function, okay, converts whatever here to a string. So if it's a digit, it will be converted to a string, right? All right. So in here, for example, all right. So message equals name. What is name? It's a string, no problem. I'm gonna go in here. Plus. So plus is used to concatenate strings. All right. Is a string, no problem. But age is not a string. So first what you have to do, you have to convert it into a string. Then you add it to another string. Alright? Simple stuff and to alright. There is many escape sequences, like /n is a new line, /tab or /tab, /t tab, /r return, quotation mark. So if you don't want to use the double quote as a double quote, just like a character, okay, you have to escape it. You have to escape it, right? Print, okay, so in here, I don't think anything new in here, just take a look at it. Alright. So for example, in here, there's a good example that you're gonna use a lot when you use the files, right? So in here, if I put only one backslash, so the compiler will interpret it as \n. What does it mean? I don't know what does it mean. Or this \p. But when I escape it, I'm telling the compiler this is just a normal character, which is a backslash. backslash, right? So for example, to make it more clear, okay, if I say print, okay, text, right? Okay, hello, and let's say C, hello, or let's say that I want to print a path. Let's say I want to print a path, and let's say C colon name, a file called name. What would be the output in here, in this one?
C colon.
This will print C colon. This will be interpreted as a new line, and then Amy, which is wrong. I have to escape it first. How can I escape it? I add one more in here. So I tell the compiler this backslash is just a normal character. Then the output this way will be C colon whatever. You know, name, whatever. Okay? Implicit continuation, we already spoke about that, talked about that. The Python shell with string text, you could try that out. Okay, that's what I was at the beginning telling you to look at the function. So what does print return? Nothing. What you could pass to it, objects. There is, when you see it inside two square braces, okay, or brackets, square brackets, that means an option. It's an option, right? So the separator will be by default as a space, but you could change it, and this will be an option, which is the new line, the end character of the line, right? Always you could play with it and change it. I think that's a repetition. So look in here. What I did in here, I changed the separator to what? To a vertical line. So when I print it, how to print it? One, instead of having a space, it put a vertical line, vertical line, vertical line. And here what I did, I changed what? The end. By default is what? A new line. Okay, but now I change it to what? 3 exponential letters. And so on and so forth. Hi. All right, so input. Now we know, and there is, by the way, we'll talk later about formatting the output. There is a lot of ways to format the output. All right. Later on, after we learn about formatting the output, we'll learn about GUI. You don't have to format. Everything goes to boxes and all of that. So right. But usually in most of the applications, like scientific applications, when you write, for example, deep learning, machine learning, whatever application and all of that, you don't have GUI like interface, right? It's just you're looking for results saved in a file, and or you're trying to graph something out of the results more than anything else. We'll talk about that later, right? Okay, so there is a lot of formatting. The basic thing, if you know how C does formatting, you are okay, because still you could format the output exactly like we did it in C. Okay, if you know C. So there is different ways of doing the formatting. We'll talk about it later. Okay, that's for the output to the screen. Okay, or output to a file. Okay. Now we need to read data. How you read the data? The CN in C++ or Java. Now we have the input. All right. So print. You could say print. What is your first name? Okay, first name input. Now it will, whatever you type in the keyboard, enter, will be saved where? In the first name. All right. Right. And then a print hello, whatever the variable there. This is, you don't have to do this. This sentence is an extra because you could include this sentence inside the input. It makes, actually that's how we used to do it in C++. So you say C out for the message and the CN for reading the value. You don't have to do that in Python. So all you have to do in Python, for example, input, you put the text you want, Okay, enter your score, and it will print it for you. Simple, right? So in here, for example, let's say, okay, input, okay, enter a value, okay, enter a value, okay, so close, okay, and let's save this value where x, for example, we'll call it x, okay. So whatever value it will be saved in x, then you could say, okay, print the value of x. As simple as that. So let's run it.
You're not showing it on the board.
Say that again.
I have to switch screen.
Oh, you're not seeing anything. Interesting. Okay, so in here what I said, input, enter a value, and print x. So let's run it. It will ask me to save it first. Sure, I will save it. Okay, what's the error in here? Is there an error?
Yeah.
What? There is one single quote in here, one single quote, and double quote at the end, right? So you have to match, run. Okay. So in here, enter a value. So this is my life tough. And then print the x printed that. So, right? So saved it in the x and printed that. Okay? All right? Again, when you go input, you need to see all the things you could do with the input. All right? Go to where? The manual. Okay? And you could learn more about it. All right? So in here, let me go in here. Okay. Three functions for working with the numbers. So integer of the data converted to integer, float the data, round, and could know how many digits you would like to round it. Okay. So code that causes an exception. Okay. So x equals 15, y equals 5, no problem. But y in here is what? A digit, a string, and z equals x plus y. What's the problem here? How can you add integer to string? So you have to fix that. So what you do, you convert the y into integer, for example, or the other one to a string, and we can concatenate, right? So again, this is a similar example. So in here, for example, input, enter the quantity. So the quantity has to be what? Number. You cannot have a quantity 5.5, or you cannot have a quantity hello. Okay, so whatever you enter in here, it has to be converted to integer and then saved in the quantity. All right. Float, if you need to make sure it's a float, whatever the program does. All right, for rounding, okay, so when you divide this variable by this variable, gave you this value, 25.5319, whatever. So if I am interested in just 2 decimals, I could do round 2 and it will give you 25.53, okay, for rounding. All right. Anyways. So there is programs. So this is a program. Which one is this in here? You know, you need to know how many miles per gallon. Okay, they are, by the way, all the programs. I added the file for you. You could download also, and all the code was also added to the canvas. Okay, so you could try them out. All right. If I were you, I don't go down the file. I don't go down the file. I type them, because when I type them, especially at this stage now, okay, you have to get used to mistakes, compilation mistakes. Okay. We did not talk about the errors you can get. What kind of errors you could get in your program? Okay. There's the 3 types of errors, right? The first one is
Syntax.
compilation errors. Compilation errors. And in my opinion, these are the easiest thing to fix. Okay, there's a problem in the syntax, go and fix it, right? That's not a big deal, all right? Okay, what is the second kind of error you could have?
Exceptions.
Speak up.
Exceptions. Like,
Yeah, exception is, it
that's
comes with the compilation, okay. Logic errors. Very tough, right? If you are experts, I don't think you'll have like a compilation error that's very easy to fix. The logic, you're writing a massive code, but the code does not run the way you want. It does not give you the right results, all right? Where's the problem here? In the logic. It does not matter what programming language you are using, whether you're using Python or C++ or Java or whatever, same disaster, right? Because your logic is wrong, so you have to work in your logic. What is the third kind of errors you could have? Anybody computer science here? Runtime errors. Thank you. Runtime error. Okay. Okay, that's why it's not run, it's run. Runtime error. That's why we have to do a lot of testing, different kind of values and test environment and all that for a program. So sometimes, if your program ends with the division by zero at a certain point, it's a runtime error. Okay, time error. Okay, it happens. The error happens depends on the data you feed. So your code does not fix all the situations. All right. Okay. So the first thing is a compilation error, and this week or next week, once we go over all the basic things, okay, you'll learn about the compilation errors. That's why I'm telling you it's very important that you try to type the code. What is even better for you to learn for learning process is just when you read the code, just read the code and put everything aside. You know the problem now. Just use your own logic to write. Okay? Even if it's a little bit different, it should be a little bit different. Don't copy, right? And then after that, if you compare your logic to this logic, okay? Then after that, later on when you are expert, you could compare your algorithm to that algorithm, the speed, how fast is your algorithm, your way of writing that compared to the other one, the performance, okay? Then you try to check for all the inputs of the data, all right? So in your code, in any homework, I need you to have it as a routine thing that you do. I need you to focus on writing your codes, your assignments. You have to have a story for me, from the beginning to the end, how you make the story with comments. Explain it, right? Then the way you choose the name for the variables and the name for the functions, we're going to talk about the functions soon, is a talent, right? And so on and so forth. And then after that, the logic. And you make sure there is no logic error. You make sure there is no runtime error. How we can protect from the runtime error? How? Cameraman, how? Runtime error. How can we protect from runtime error? Writing exception statements. Very good, thank you. Exception statements, right? Huh? Try catch and all of that, right? So we're going to learn about all of that, all right? Basic things. You go for a job interview and you write the problem they give you without all of these modifications, simple things, testing things. He's not used to writing code in the right way. Until if you don't write the code in the right way in this course or in any programming course you take, you'll never be able to do it. You forgot. Okay, you forget. All right. Myself, when I write code, I build the skeleton first, I know where I have to add the comments. I try to write the story, and then I fill in the blocks. All right. All right. So we'll learn also the when you learn about object-oriented programming, you have to divide your problem into classes. Each class has multiple methods. We call it methods in the class. The method has a function to do. All right. You don't lump sum, put everything together. It will become, okay, so you just a class by itself, then a class by itself, then a class by itself. Then you create a main class to call all the classes for the functions. Very simple. So you divide your problem into smaller problems. Each problem does its work, right? Anyways, what time is it? All right, so a few examples. I need you to take a look at them. I don't have time, I'm late. So you take a look at them, and they are available for you. You could just download it. So let's take a look at the statement. What is the statement? Statement is the smallest unit of code that Python can interpret. So for example, print statement, assignment statement, and so on and so forth. Okay? So a program of Python usually contains an ordered sequence of statements. The interpreter will execute the statements one after another. This before this. It's not going to, right? Top to bottom, just as you normally read the page, right? So let's talk quickly about the values and the data types. So we already spoke about that. So we know what's a value. You have a variable. It could have a value, and the variable could have a data type, integer, float, right? But you know, if I'm confused in my program, I would like to know what type of this variable. Very simple. There is a function ready for you. All you have to say, type. Type hello world. What is type? Function. All right. Then you know the thing you would like to check, and we'll tell you this is a class of string, class of a float, a class of numpy, a class of panda, a class of array, a class of whatever. All right. Remember that everything in Python is built of classes. So string is a class of string, float is a class of float, integer a class of everything built of classes. All right. Now you might not need to know what is the type, but you know when you go further and you start working with multiple modules. Pandas, you know, you could create like arrays with pandas. You could create an array with numpy, so you don't know if this array is created with panda or created with, and so you need to check the type. So myself, the type statement I use it all the time, especially when I debug. Right? So this is a very important function. Okay. Anyways, there is a float. There is like a complex number. Let's not worry about it right now. We spoke about the variables. A variable is a storage location. I don't have to go over that. If the variable is not defined, okay, if the variable is not defined, assign the value. What does it mean, defined variable? It means assign the value. You define a variable when you assign a value to it. If it's not defined, trying to use it will give you what? Name error, because it's not defined. So before we use any variable, we have to define it. What does it mean we have to define it here? You have to assign a value for it. You have to assign a value for it. Anything important here? You can take a look at it yourself. Okay. Operators. Okay, what are operators? Operators are special symbols that represent computations like additions and subtraction. Okay, so for example, okay, if I need, for example, okay, to add 1 plus 1, what is this? An operator, addition operator. Is that all we can add? We could overload this. Overload. I'm sure you have done overload, right? Overload it. So if I have, for example, circle. Let's say I have a class called circle. Okay, circle, right? Circle. Okay. All right. okay, I create two objects, circle x and y. I could also say x plus y. What does x plus y mean? I have to overload it. I have to give it a meaning. I have to write a code for it. So this could be like add the area of circle x to the area of circle y. So for this code, for x to do that, I have to program it, overload it. So any operator, as we'll learn later, we could overload it to our function. All right? By default means adding. Okay, another example we already used for overloading. All right? So when we say the default is, for example, 1 plus 1 equals to what? 2, right? If I say h plus h, what is it? What plus means in here?
Concatenation.
Concatenation. That's an overload. There's a code called overload. When you have a string added to a string, that means concatenation. Not by default, you know. For us, by default, given to us. Okay. All right. So, for example, I could overload this also. Okay, I could overload all of this when I say h plus h, for example, like that. I could overload it to be, for example, takes the first one capital, the second one h. I could do whatever I want. I could overload any. I could rewrite any function the way I want. I could overload any operator. Okay, later on, right? So these are operators that we, you know, you could, okay, and that's what matters, operators. Anything in here? Okay, there is bitwise operators, okay? So for example, in here, what does it do in here? Left shift. What does it mean, left shift? When you left shift a number, what do you do? Multiply it by 2.
Okay.
Right? Because if you have, like, for example, okay, if you have, what is this?
3.
Huh?
3. It's binary?
Binary. What is it?
3.
3, right? If I do left shift, what does it mean, left shift? I add 0 in here. So how much the value? 6.
6.
Right? If I do another left shift, it becomes how much? 12. 12, right? Right? Okay, how about right shift is? Divide by 2. All right? From your digital design 1, right? Right. So divide by 2, right shift, left shift, and all of that, okay? This is bitwise and, bitwise or. This is like exclusive or, right? This is returns the complement. You know, it's a complement 0, 1, 1, 0. So there is a bunch of bitwise operators that you could use. I give you some examples in here. Take a look at them at your time. At your time. So, for example, enter number 1, 10. Enter number 2, 2. Okay. After left shift by 2 times. So when left shift for the 10, that the first time you do left shift, it becomes how much? 20. Then the second left shift becomes 40, right? And so on and so forth. Okay. Expression is a combination of values, variables, and operators. A value, okay, so this could be an expression. It's not a statement. So we say always every expression is a statement. Okay, but not every statement is an expression. The order of operation we already spoke about. The assignment, multiple assignments. So in here what I did, I assigned 3 to z. The value of z assigned to where? To y. The value of y assigned to x. This thing, maybe we did not see it in C++ before, but it's possible in here. Also, we could have the update, right? You know what's the update? The update is to update the value. So a equals 1. In math, this is not allowed, but in computer programming languages, are allowed. So A, how much is A? 1. 1 plus 2, 3. 3 assigned to A. What is the value of A now? 3. And here what I did? A multiplied by 3, which is 9. So what's the value of it? That's what we call it, update. We call it update, and I'm sure you know. Strings, we already spoke a lot about strings, what we call strings. The most important thing I need you to know is, okay, that if you need to have a multiple line string, you could use 3 quotes. So 3 quotes in here, more, second line, it will print it in 3 lines like that. So this is one thing you could do in Python, that you could have multiple line strings. How you do it? Okay, how you do it? By print, for example, print, okay, hello, my name is Shakur, for example, and 3 quotes. So it will print it exactly like that. It will maintain the new lines. Okay? Clear? We spoke about comments, and that's very important for me when you do the doc string. So when you write a code, with doc string, if you use help, you could read the help through the help command. You could read the explanation of the function. So the doc string is, you could have single or double. As important, they are 3. So you could have single, 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 or double, 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 and you have to end single, 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 or double, double, double. Okay? And whatever, that's what they call it, doc string, which is multi-line comments. Multi-line comments. Okay? Multi-line comments. So you could have multi-line comments in 2 ways. Okay, 2 ways, like this. That's the first line, second line, 3 line. Or you could have like this, and whatever the 3 lines you need. Okay, which one is better? This one. This is always much better way of writing the. Okay. So console input output, I already gave a lot of examples in here. Block structure, I don't have to repeat that. So you have block, this is block 2, indentation block 3, this is part of block 2, and this is block 1. And this is the reason for a lot of logic errors. A lot of logic errors. So you have to be careful when you indent. Right. All right, let's have a break for 10 minutes, and then we'll come to talk about function, flow control, etc. etc. Thank you. All right, we'll. Alright, so we're going to talk a little bit about the functions of flow control, logic and condition, and loops and iterations. Alright, so relational operators, you know, like any other language, equal to, not equal to, greater than, less than, greater or equal, less than, right? Nothing new here, right? Okay, so, I mean, the Boolean expressions are used a lot in your programming language, so they are similar like any other language, I think. So just be familiar with it. So in here, age equal 5. If it's 1 equal, that means it's an assignment, right? This is like Boolean, it's like checking. So what is the answer of this? It's a Boolean, either true or false. So if the age is 5, then 5 equals 5, then it's true. Otherwise it will be false, right? So it will be true and false. And the true and false are keywords. True with a capital and false with capital. They are the Boolean true value or Boolean true false. All right. Also, there's logical operators and or not, which is like exactly any logic in any programming language. Okay. So, for example, take a quick example: the AND operator. So, if the age greater or equals 65 and you see the and in here. Okay, the city equals Chicago, then it's true. Otherwise, it will be false. So I'm not going to explain what is and or. It's the logic sentence that you did in your design. Very important functions, 2 functions, especially when you work with strings, is lower and upper. Okay, because as you know, I mean, you know, R, for example, R. Does not equal R, right? Right? So if you need to compare strings, you need to make sure, for example, to make sure they all have the same case, then you compare them, okay? As an example, if you have a program that you need, for example, enter the value, it could be no or no. For your logic, or no like that, right? Or no like that, right? For your, okay, right? So all of them for your logic will work. It's a no sentence. But when you compare them as a text, it will give you different results. It will give you different results because they are not the same. So what you have to do first before you compare, okay, you have to lower them. So if you lower, for example, lower this, will give you what? No. If you lower this,
Also no.
okay, will give you what?
No.
No. You lower this, give you small no, and so on and forth, right? So for comparison, when you compare text, you want to make sure that all capitals or all small, right? So a very important two functions that you need to use. Okay. All right. As we said that Python is built of classes, and each class has methods. So if you need to call a method from a class, you have to call the class first. So for example, in here, okay, we'll talk about this later. So for example, so if I have a string in here, Mary, and string 2, Mary, does string 1 equal string 2? Yes. Okay. String 1 equals string 2 because they are the same case. All right. But why it gave me false here, I don't know. Maybe it's a mistake. Okay. But if I do string 1 lower and string 2 lower and I compare them, okay, I compare them, if I lower them, then will compare them, it will give you a true. Print string 1, Mary. Oh, so this is a mistake in here. It's supposed to be small, but in my PowerPoint it's like capital. It's supposed to be small. Got it? So this is supposed to be like small like this. All right. Anyways, you got the idea. You got the idea of the lower and upper. It converts everything in uppercase or lowercase. And it's very useful for when you compare text, right? All right. Anyways. So the first Boolean expression or the first statement we're going to learn about the F. It's the same like any if statement you have learned in other languages. Okay, even simpler. So you have F, Boolean expression, and we said F, it has to end with colon. For has to end with colon. While has to end with colon. Don't forget the colon. All right? Don't forget the colon. So F, Boolean expression. If it's true, what are you gonna do? Run the statements in this block, and you have to notice that there is indentation. If it's not true, you're gonna go else F, another Boolean expression. If it's true, you're gonna run the statements here. And the last one is else. So you could have F, else F, else F, else, multiple else F, and it ends with else. All right? So if the first Boolean expression is correct, you're gonna run the first set of statements. If not, the second one is correct, you run the second set and then exit. If not the third, then go out of the F. If none of them are correct and the else is correct, it's gonna run. None of them correct, and the remaining is else. Else will run. Right? Like any other if statement, there is nothing new in here. So, for example, if age greater than 18, print you can vote. You may vote. All right. In here, for example, if age greater than 18, print you may vote, else you are too young to vote. Okay, in here, multiple. So if invoice total greater or equal to 100, then discount percentage is 2%. Else if invoice total 250, then the discount percentage is 10%. Else if invoice total greater than 0, then the discount percent is 0. Else invoice total must be greater. I mean, if you enter like invoice total in minus, you cannot calculate the discount, right? Very simple usage. In terms of language, it's a very simple usage. Where is your talent? In the logic. In the logic, what you gonna put in the logic, in the sentence, right? All right. So a program, you could run it, also available for you, is for a grading score. So what is the score? You enter the score, input the score, and the score always integer. Okay, 90, 95, 60, 65, whatever the integer. Okay, if the score is greater or equal than 90, then the grade is A, else F, B, else F, C, else F, D, else, hopefully you never see this grade, F. Right? Simple code. So where's the talent again? Is in the logic. And here, another way, if the score is greater than 90 and less than 100, then it's A. Greater than 80 but less than 90, B, and so on and so forth. The logic. All right? Depends on your logic, that's what will be your logic. All right, so the same thing, you're reading the score. If the score is greater or equal, if the score is greater, the score, there's something wrong with this sentence. If the score is greater or equal score, and lesser or score, I don't know what's this. If it's like between what score and the total score, whatever else, anyways. Huh?
The first score was probably meant to be something else.
Something else, yes. There is a good statement that you could use alt pass. Pass, you don't do anything. So in here, what you say, if the customer type equals R, retail, for retail, or customer type equals W, for wholesale, for example, okay, pass, don't do anything. If he's both, don't do anything. Else, print, customer type must be either or. Okay, so in here, in this sentence, what's the logic in here? You're trying to verify what kind of customer you have. The customer has to be either retail or wholesale. If he's neither, then something wrong, right? So the best sentence, you could use it, okay, when you do nothing. Okay, it's like a place holder, right? So this is a program as a given for you. Try it, run it, code it. It's available for you. So type of the code R for retail, W for wholesale. Okay, if the invoice total is less than 100, discount is 0%. Greater than 100 but less than 250 is 10%. Greater than 250 is 2%. If wholesale, they have different range. I'll ask you to write a program for that. Can you write a program? Simple logic, right? Using if statements, right? Very simple logic, But anyways, the code is available. Here is a code. Okay, you could try it, and okay. This is a CD code, and this is the code for you is available. Okay, you could run it. So this is another program is available for you. Just try it out. Okay, the miles per gallon. How can you know the number of miles per gallon? Very simple. Enter the miles driven, 150. Enter the gallons of gas used. Okay, should give you an error. Why? Because you have to give a number for how much you have driven, right? And that's the other thing. In your writing code, you have again. This is fixing what part of errors? Logic errors, right? Or runtime errors could be, right? All right, so when you're trying to calculate the miles per gallon, right? So you have to enter the miles and the number of gallons. But if you enter the number of gallons 0, does that make sense? Does not make sense, right? So this is kind of a runtime error they're trying to avoid. And all your homeworks and all of that, you have to take care of that. Okay, that a customer could enter a wrong data, that wrong input that is not useful, right? Okay. This is another example. So the miles per gallon, enter the miles driven 150, enter gallons of the gas used 30. Then it does the calculation. You wrote the code and then by. Here they give you an error. Anyways, the code is written for you in here, and you could just download it to your desktop from here. Try it, play with it. Okay, again, my advice always try to type it. Okay, don't even type it. Just put the program aside and write your own logic. All right, and then see if you can do it. That's how you learn. Okay, that's how you learn. Even if you are a good programmer, you'll not program for a while. So that's what you need to do here. There is another program given for you. This is for anyways, I think we'll try it. Okay. Let's go to the while sentence. The while sentence. Everybody use while, right? So while sentence, while, Boolean expression, again, while has to end with colon, and then statements. A while loop that continue as long as the user enters while. So for example, you set a variable choice. Yes. While choice, what are you doing here? Lower it. Why? Because the user could enter capital or small, does not make a difference. For your logic is okay, but for your program, unless you make it lower, it cannot compare right? Print hello. Then you ask him to enter the input again. If he enters yes, what will do? Loop again, hello. Yes, hello again. Until he enters no. Then it goes here, it will exit. Give you by. So hello, say hello again. Yes, hello, say hello. Alright? So again, while statement in here is very simple. Very simple. Where is the talent is in your logic, what you want to do with it. As a language, it's like a very simple. So in here, for example, counter equals 0, while counter less than 5. How much the counter is now? 0. Is it less than a 5?
Yes.
Yes. What I do? I go inside the block. Print counter with a space. Then I add it. Now, how much is counter? 1. Is it less than 5? Yes. I enter the loop. I print the 1. Now it's 5. Is it less than 5? No. If it's less than 5, I don't enter the 1. I go from here to where? To here. Okay. I don't enter the block. I go from there to there. Okay. While it's true, what does it do? While it's true. Infinite loop forever. If I write while it's true in your computer like this, and then pass, for example, what you have to do? You have to end the terminate the program, right? So, because it's gonna give loop, right? Okay, so inside is what you have to do. You have to have break. You have to do Control C, or inside your code you could have. Okay. All right. So the for sentence, the same thing. For it has to end with colon. Don't forget the colon, right? For, and there is a range function. There is multiple ways to do it, but there is a range function and variable in a range. Variable in the range. So you go the first value, the second value, the third value in the range, and all of that. Okay. So before we use the for, we have to learn about a function, very, very, very important function called range. Range. All right? So range. So range. So for example, if I say range 5, so how many numbers I have the range in here? 5. It starts from 0 up to 4. If I say range 1 to 6, so you start from where? 1 up to 5. So 1, 2, 3, 4, 5. 5. Okay? 2 to 10, I start from 2. up to
8.
10. But the step is how much? 2. Okay, so 2, then 4, then 6, then 8, then
No.
10 is not included. Why? Because it's not inclusive. So the first one is inclusive, the end is not inclusive. It's not inclusive. Rules, that's the rules. Okay, that's the rules. Okay, that's the range. It's very important to know how to use range. Okay, because most of your for loops, you're gonna use the range, right? And here, for example, range. Start from where? 5. End where? 1, right? The first one is inclusive, the second one not inclusive, and this is the step. What's the step? Minus 1. 5, 4, 3, 2, 1. Okay? The 0 is not inclusive because the second one. Okay, that's the rules. Alright? So when you look in here, for example, for I, a variable, I in range. So first of all, I have to know what is in range. 5. What are the values in 5? 0, 1, 2, 3, 4. Print I with a space. So it's gonna print 0, 1, 2, 3, 4. Right? Look in here, number of sum of the number 0. So I'm adding. So range I and range 1 to 5. So what are the numbers there? 1, 2, 3, 4. 5 is there? No. So I'm adding 1 plus 2, 3. Plus 3, 6. Plus 4, 10. And that should be the result. Right? So again, very important to understand how. Okay. Now, we learned from previous languages about the break and continue, right? Everybody knows break and continue. What's a break? Break out of the loop. Okay? Break completely. Get out of the loop. If something happens, get out of the loop. Okay? So, break. So, if data equals exit, where I go? Out of the loop. How about continue? I don't complete this current loop. I go from the beginning. All right. So break and continue. So in here, for example, let's take a look at this code. Print. Enter exit when you are done. While true. While true will loop forever. Forever. Okay. If data equals exit, then you break. Otherwise, you read the data, the data will be saved in a variable I, and then you print it. Okay, and you print this square. So enter integer 2 squared, 10. 10 squared is 100. Then you enter 23, it will give the square. If you enter exit, it will bring you where? Outside of that loop. Logic you have done before. I'm wondering why I'm covering this, but again, I'd rather start from the very beginning, pick you up, okay, with me in this journey, okay, and give you some time to, refresh your memory about programming. I mean, technically, what I should skip all of this and go to data science. But I'll be willing to waste like the first 3 lectures, giving you all the basics. Okay, just want to make sure everybody is riding with me, safe and sound, right? But after that, we're gonna fly, all right? I already explained continue. So continue, what does it do? It will skip this loop, iteration, and bring you to the next loop, to that next loop. And by the way, I mean, understanding how break and continue work is very important, makes you a good programmer. Because a lot of the logic needs the break and the continue, especially with while. Because usually in the while, what we do, while loop forever, while true. And something happens inside, either makes you break or makes you continue. For is different. For usually you are going through a range of numbers. All right? So tools, these are simple tools that you really need to know. So for example, in here, investment is 1,000 for I in range 20. What are the range in here? Starts from where? 0 to 19. 0 to 19. So how many loops they have? 20. I'm gonna loop for 20 times. All right. Whatever it will be done, we'll calculate the interest over 20 years, for example. All right. So this is a program to calculate the investment. I think we ran this last time, the monthly investment and how much. So also I gave you the code. You could try the code as you wish. It's the code there, right? And also written for you in here. And by the way, in the PowerPoint presentation, there's two ways to download the code. It's like you have like icon like this. Also in the comments. In the comments, watch the comments in my PowerPoint presentation because I write a lot of information. And the codes are there, so you could cut and paste the code, all right, and run it. Okay, so whatever you want to do, you could do. I don't want to go over that. There's no time. Okay, last thing in this lecture is function. So what is function? It's a block of code to do a job, right? And to write a function in functions in Python is very simple. You start with the def for definition. You give it a name, inputs, colon, and logic. Okay? So if you need to write, for example, to a simple code, for example, to calculate the area of the square. Okay, a square. So def. Okay? You're going to give it a name. What's the name of the function? Area. Area. Underscore of square. How is that? All right. And the input. What you have to give as input? The side length. The side length. What's the side length? It's called x. Right? And def, we have to have column. Right? All right. So return. What they have to return?
X squared.
X. If I need to call it what I have to use? Area of square 5. Let's save it in Y. What would be the result? 25. 5 squared 25. Okay? Simple function. So functions is very important. Alright. Now the functions inside the class is what we call them. Functions inside the class, what we call them? Methods. Okay? Methods. So there's the same thing. We call them methods. Method and okay. So the same thing. Any function has a name, has a parameters, and has a return value. The funny thing about Python functions, you could return multiple values. Not only, I mean, in C++ and Java, how many values you could return? One. In here, for example, you could say return like this. Return x squared. So how many values you return? 2. When I call it, it's going to return 2 values. For example, z and y, like this, z and y. Which is cool, which is kind of cool. Okay, you can return multiple values, right? That's what it does function. So in here, for example, this is like this circle area. This example is a circle area. So look in here. So def circle area, what do I have to pass for circle area? Radius. If I know the radius of any circle, I could know the area of the circle. Return, this has to be here by the way. This, return what? 3.14, what's 3.14? Pi, multiplied by radius what? Squared. Same thing, okay? Okay, so, you know, take a look at that. Anyways, you could have multiple parameters, and here we have only one. But if I have it for rectangle, how many parameters I have to pass? 2. Yeah.
Okay, have length and height maybe, or width, whatever. Okay. All right. So you could have. So for example, in here, def play more answer requires a parameter. Anyways, so print goodbye if answer is within n or no, else keep going. So it's like so this is like a function of play more. If you enter n or no, it will loop. Okay, else it will keep going. Will keep going. Anyways, so what I want to say, okay, before I go to lambda, all right, so let's say I have a function, let's say def, let's call it if un, okay, and they have three parameters, x, y, z, colon, whatever the logic, okay, and by the end return whatever, return whatever, you know, t for example, whatever, a value, right? So how many are the inputs in here? 3. All right, 3. So when I call it, for example, if I call it fun, say 1, 2, 3. Is there a problem with this? No problem, because there is parameters. What if I say fun? 1, 2.
Error.
Why error?
Because you just give the 2 parameters and there are 3 there.
Because I have 3 parameters. How can I fix that? By having a default value. So for example, if I say, for example, x, okay, equals 0, y equals 1, z equals 3. So in this case, okay, when I call this function 1, 2, so what is the value of x? 1. Y? 2. Z? 3, because there's a default value. There is a default value. Okay? So all of the parameters, I could initialize them to a default value, and when I call a function, I could change it. All right? Okay. Now, what other conditions? They have to be in order. What if I need to mix them? I don't need them in order. What if, for example, I need to pass only the z value? I need to use the default of x and the default of y, but I need to change z. So very simple. What I do, z equals 15. I put the name of the parameter, right? So in this function, how many parameters has to have? 3. What is the first one? 0, the default. Second one? 1. Third?
15.
Okay. What if I do like this?
Also 3.
So that's all the defaults. So it's very simple, very logical, right? For you, the best thing always to have defaults whenever you can have defaults in your code, right? If you can have a default, make a default. Okay. Number 2, always try to call them in order. Okay. Okay. Also, it's good, you know, always when you call a function, put the name of the parameter. It will take you longer, but will make your code cleaner and cleaner. Okay. All right. So as simple as that. So there is a shortcut for writing a function called lambda. Very simple. Lambda is very simple. Look at this example. So lambda is, you use the word lambda and the parameters. So what are the parameters in here? X, Y. You could have Z. Okay. Let's say I would like, for example, to calculate the cube, for example, the cube volume. Okay, so I could say lambda the x, y, z. What is, I mean, like, I mean, like cube could be also, it's not a cube, but they call it, you know, with different, sides, right? So what is the volume? X multiplied by Y multiplied by Z, right? And this we'll call it, for example, value, right? So in here, for example, I'm calculating in here the, the square whatever parameter, whatever, okay? So this is add 2, or add 2 numbers, right? So now add 2. So welcome to IoT. Welcome to the IoT class. Right, time sheet, sign-in sheet. Everybody signed in. All right. Thank you so much for coming. And this class, it will have it's a little bit different than other classes, all right? Because all my life I would like to give exams, tests, and most likely I'm not going to give you any tests in this class. Okay, in return, you're gonna work 10 times harder than working for exams. Right? Okay. So that's the deal. Let me close the door. Okay. So today will be easy class. We'll introduce you to IoT. What is IoT? What's end-to-end programming? What we are expecting from you in this class. What you're gonna do. First of all, this class is a graduate level class, but seniors are very welcome, or undergraduate, very welcome to take this class, assuming that they have some programming background. I always wonder, are these for? How can we use them? Anybody know? Oh, we could write? It's not.
It's a little off.
It's a bit off.
It's very nice, and this is supposed to do like this, right? Okay. Interesting. All right. So IoT is, first of all, if you don't know me, anybody does not know me. Okay. Everybody knows me. You know me? Do you know me? First time you see you in my class.
That's because I dropped the last
Huh? You dropped the last one? The last one? Okay. How about you?
You gave a lecture.
Okay, then you know me. Okay, I'm good. So if you don't know me, Professor Abu Znaid. Okay, and my extension 4113. My email at projmal.edu. All right, and my office in engineering. Take, I think 152, room 152. You are welcome to call, email, stop by at any time you like. All right, so what we are covering in this course, we're covering IoT, all right? So I know a person knows IoT very well, all right? He knows IoT, kind of, right? The reason for that, he published paper in RFID with me, actually it's a journal, and it was related to security, but RFID, right?
Yes, sir.
And RFID is, if you consider it as part of IoT. So IoT is Internet of everything. Everything. So everything means what?
Everything.
Means everything. So basically, look at this room. In the future, the tables will be connected to the internet. The chairs will be connected to the internet. The doors, the lights, the blinders, the windows, this, that, clock, everything will have kind of IP address connected to the internet, right? That's the future. That's the future. Why we need to have? Why we need to do that? For many reasons. We're going to talk about it, right? We're going to talk about it. We'll introduce in a second. But that's the future. If you go Google, try to go Google and try to search. Okay, what are the most trending technologies nowadays? You'll find some sites will give you 15, some of them tell you 17, some of them tell you 7, depends. But in all the lists, I bet you'll find IoT, Internet of Everything, or Internet of
everything, all right? And that's the future that everything will be connected to the internet. If we are able to secure the communication, right? So you don't want to have your husband, not your husband, your wife, or your husband, if you are a female, for example, has a control over your diabetes device. So in the future, we're gonna have a diabetes device connected to you, okay, that the doctor could monitor or whatever, but you don't want your ex hack into it and inject you with something you don't like, right? You don't want to have your garage door, okay, hacked into that people could get to your house, right? So we'll talk about security, we'll talk about the things. Anyways, before we start talking about what you are supposed to do in this class, okay? And you could decide you want to stay and or leave, okay? But you are going to do two major projects. One of them is research project, and one of them is hands-on project. So for the hands-on project, we're gonna have a lab. So in here, we're gonna cover a class for 2.5 hours, but you're gonna have another lab that you have to take, all right? And I have created a manual for lab. So basically, you're gonna go to the lab. You could work in groups of two people, okay? And you'll be able to learn about Raspberry Pi, about Arduinos, about different experiments, introductory experiments that you'll do step by step, and you could write the code for them. So that's will prepare you for that first project, or call it the second project, I don't care, which is a practical project. So you're gonna come up with a project that you'll plan for it, you'll have a budget for it, you'll plan, design it, you'll have a, let's say that economic or, need for it, business plan for it, call it, we're gonna talk about it in details, and you will build it and present it at the end, all right? So I'll give you some of the examples we have done. My GA will show you one of them. When he comes, he's not here, he will be here at the end of the month, but he used RFID to create a sign-in sheet. As you see in here, for example, every time you come to this class, what I have to present with your paper. Or I could do it in the computer to sign-in sheet, right? So it's a time consuming. I don't know who signed what, so you could very much sign for your friend, okay, all right? Or you do whatever, right? Okay, so it's like an old-fashioned way. By the way, in Canvas, I could do it. I could call the names and sign you in, right? But again, that will consume a lot of time. So my student, he created a system that, he created an application using, I think, Uno or Raspberry Pi. All right, you plug it to a laptop through the computer. Okay, so when you come, just you put it here as a professor. I put it in here, and using your UPID, when you enter, just you scan it. Okay, so it will scan your ID, because your ID, by the way, is RFID. It has a chip inside it. That's why you are able to access doors. So you scan it, all right, and scan it, record the time you came in, the time you left, whatever information, and is connected over the cloud where? To a database, to the cloud, okay, and could, create all the data. So I could know exactly what time, the minute you came to the class, the time you left the class. If you attend, you did not attend, I don't need to have a paper or anything, right? So this is an IoT application. The next phase he's working on, integrate this with the Canvas. Okay, so the Canvas. So, the data gonna go to the cloud will update my Canvas, so I don't need to do anything, all right? The next step, I don't wanna bring this device, okay, or a laptop, okay? I need it to be hooked to my iPhone. I don't wanna touch your phone, but I can touch my phone, okay. All right, so my phone, okay, so there's a serial port, so I'm gonna plug, that's what you're gonna work on it, just plug it in here. So I put my cell phone, plug it to here, and you scan it in the way it doesn't want to do anything. This is IoT device, so this is an IoT device using RFID. The other application my students have done last semester, last time I offered the class, is like, in winter, what do you have? You have oil, I have gas now, but many people in the area have oil, right? And for the tank, right, you have, when it's like about 20%, you have to call a company to fill it out. Or usually the company, when they run by and they estimate, and sometimes they give you more oil, okay, than you need, or you could have the summer a lot of oil or whatever, so you don't want to worry about that. So we created a device, okay, with a thing, again the pi, all right, where it measures the level of the oil, and the pi connected to Alexa, Alexa, Amazon Web Services, right? And at certain level, it will issue the request for oil, okay, by itself. So this is another application. All right, another application for IoT is like monitoring your bag when you travel. When you travel overseas, you come in the GFK. You have to finish the customs and then you go wait for the bags. The problem, there's so many bags, right? You have airplane has 500 people, so many bags. So one time it happened to me that, my bag kept circulating, but I could not recognize my bag, right? So this is one of the application that, you have like, application in your cell phone with RFID or whatever chip on the bag. When it passes by, tell you it's coming, all right? So think about any application. Okay, so what we are doing in here. So how many of you already realize what we are talking about? All of you, almost, right? Almost. So what we are talking about is 3 layers: sensing, okay, and then we have communication, and we have communication network, and we have a cloud. Okay, so you're gonna have a system for sensing. You need to sense the data. The data does not stay local. The data will be connected somewhere using Wi-Fi, for example, using RF, using whatever. Okay, wireless could be. There's no problem with that. The data will go to the cloud. The data will go to the cloud, okay, and the cloud does 2 things, all right? 2 things, okay? Processing in both of them, but it could be a real time or it could be for analysis, okay? So for example, let's say that the sensing in here, that another system, which I would like one of you to create it in other project. Now the delivery problem, right? Let's say you buy a refrigerator, or you buy a carpet, or you buy a couch, or you buy anything to your house, from Home Depot, from anywhere. All right, so usually they schedule it for delivery, right? So the problem when they tell you have a window from 1 to 5, you have to be there, or somebody alert with ID, keep your pets away, the instructions, right? So how about if we can create a system which is like a camera at the door when a person rings the bell, it activates a camera. This will, over the cloud, activates a signal to your iPhone, to your cell, whatever, okay? And you'll be able at that time to watch the person at the door. You will be able from there to open the door while you are watching, and giving him instruction where to put it, and until he leaves. When he leaves, tell him bye-bye, then you make sure the door is closed, and you don't have to be there. All right? So what kind of processing we have in here? Real-time. Real-time application. All right? So this is an example for real-time application. All right? Let's give you an example for analysis, all right? So for example, when you go, now all the stores in the future, Home Depot or let's say Macy's or whatever store,
everything will have a tag, RFID tag,
Yeah.
that even when you touch it, it knows somebody touched it. Okay, touched it. All right? All right. It will be able to report at the end of the day if it's still existing or not existing, right in the store. All right. So let's say that Home Depot, they have like 5,000 or 10,000 stores in the country. Okay. By the end of the day, they could collect the data, and what they do? Analysis. Then, according to the analysis, they know
Trend.
the trends. They could know many things. They know what parts you have to order. They could know which store that part is much more busy, or which state or which city. You know. So, for example, if you have shovels in Connecticut, will be very common, but in Texas will be less common, maybe. Right? That's simple. But this is simple. You don't need maybe the IT system, but there is other things that will need a close look, right? So we are not creating a real-time application. What we are creating, analysis. Over a day, over a week, over a month, over a year, over a history, analysis, okay? In all the process, what we are doing, collecting data. Big data, huge data, all right? Huge data. So where is the data gonna go? Cloud.
Doesn't have to go to the cloud.
It doesn't have to, but it's better to go to the cloud, to central place, right?
My basic question is the cloud a necessary ingredient in order for your project to be under IoT?
No, it's not. But that's the ultimate. That's the ultimate. That's that's the bigger picture. Because if you have like an application, IoT application for one store, do you need to have put it in the cloud?
Not
No.
necessarily.
But if you are a Home Depot that has 5,000 stores,
That's more cost effective to have it in the cloud than individual servers.
because you need to analyze for all the data, not part of the data.
But if it's only in one store like that, as you mentioned,
Yes.
is it still considered an IoT
Yes,
application?
yes,
Still is.
yes. All right. Yeah. I mean, you could always consider this is like a local cloud or null. Okay, you could null any layer, right? Okay.
So IoT is not necessarily connectivity to the internet, it's just individual devices that somehow feed to one central.
Well, I mean, the devices should maybe not connect. Should not connect to the internet at all. Connect to the local device, and the device connect to the internet.
Sure.
Okay.
Gateway, like a gateway.
Yeah,
Right.
I'm actually working on a project like that for my employer now,
Yeah.
where we're using our ID badges for printing.
Yes.
So in order for them they can literally just go and send a job to the print queue and walk up to any of the Xerox machines that are in their building, swipe their badge, and then release their job.
Excellent. Yeah. So I mean, there is no IoT is kind of, or M2M is like kind of new field. So there is no strict definition for what you do more than the vision. I mean, what common you have there is the vision. What is the vision?
Connectivity.
Make your life easy. Okay, easy. Don't work. Collect the data. Okay, that's what the vision. Okay, there are sub-visions like connectivity and all of that, but all connected. Okay, so basically, what is the main component of IoT? Sensing. All of the time that you have to have a sensing, right? We'll talk more details as we go on. Okay, so go back. So that's the lab, right? You're gonna have a lab. We're gonna introduce you. We'll give you like the gadgets, the single board processor, and you'll try to run some programs, etc., etc. Okay, then you're gonna come up with your project. I just mentioned some applications for you. So I need you to be innovative. Okay, I need you to have like a business plan, innovative things. I mean, somebody, for example, could suggest I would like to have light controls. You could buy it now; it's available, right? Okay, or like control of the lights from remote or something, curtain control, whatever, temperature control remotely, whatever. I mean, this is you could go buy them now. They're commodity, right? It's not a big deal, right? Think of, I mean, the idea. Usually, the idea. You know, one of the things my dad taught me. He said, you know what is the most important thing when you build a house? He said the material used. He said no. He said the land. He said, what do you mean? He said you're gonna go buy a land which worth $1 million, and you built a house worth $1 million. This is $2 million. But if you buy a land that's worth $10,000 and you build a house $1 million, this is $1,010,000. Okay. So you're gonna build the house. You have a vision. Your wife has a vision. Your spouse has a vision for the house. You're gonna build it anywhere, right? But what make a value for your house is the land. Reflect in here. You could have a project that you work like 200 hours to make it work, but it's not worth it. All right. Okay. The idea is not great. All right. So you need to work a little bit on the idea first. The idea first, then you spend your 200 hours, right? Because you're spending like 200 hours in the idea that's worth it, okay? It's completely different value, has completely different value. Spending 300 hours in idea that's not worth it. So somebody tells me the project is, I would like to control, as I said, like the lights in or the heat or the AC of the house remotely. Please don't suggest this project. It's very simple. It's a great thing. It's a very good thing, but it's already available. So think about something that makes life. Myself, because the attendance is a problem, I suggested this to my students, and I'll show you a demo. It's working very nice. Okay. Once we do it, it will become. I mean, I think we could market it very easily for schools. I mean, devise $50, all right, for the instructor. The university will buy for students, for the faculty.
The ID thing?
Yeah. Yeah. So, and so on and so forth. So the idea is very important. That's one side. That's a ticky side, right? That's the side you'll enjoy. Okay, enjoy. The other side that I have to make you enjoy is the research. Okay, the research. So there's a lot of development. What's happening in here? Development, scientific development in the sensing. What's happening in here? Scientific development in the protocols used. Okay, what's happening in here? Development in the cloud, in the security, all related to IoT, scientific research. So you'll be required to read IEEE, ACM, high impact factor, scientific papers. It's all about reading, understanding, and try to contribute something to the whole world. Okay, research, you're gonna do research. Okay? And it's again research, not search. Okay, search to search for something, research is to find something. It's different, okay? So we'll talk in details about it later, what is research and what you need to do. I'll try to guide you a little bit to go through some of the papers, and so mostly we'll be reading, summarizing, lab, coming up with ideas. All right. I will hold off on deciding on the lab time until next week. So until your schedule is clear, all right, we'll discuss it. But we're gonna have a lab, okay? All right. So this class is again. I don't know. I could get crazy and ask you to do an exam, but for now, I don't feel like giving you exams. You're a graduate. You're mature. Okay. I would like you to enjoy, giving a product. Take it as a fun course, to prove your engineering skills. Okay. And introduce you to research. Many of you, especially like undergraduate, I see many undergrad here. Are you undergrad? Undergrad. And the two undergrad there. Are you undergrad? No, grad. How about you? Okay, undergrad. You are still? Yeah. In so many years now. It's about to. You took my Python class, right?
Yeah. That was 2 years. But that was
Okay. Yeah.
2 more years.
Well, then he's trying to prove he's smart, so what can I do? He took Python when he was sophomore. Anyway, Good. So all good. Any questions for me so far? right? So for the lab purpose, for the project purpose, we need to divide ourselves. Sorry, we need to connect ourselves in groups of 2. Okay, no division. Okay, so you could feel free. I'll create in the canvas like a group, so you need to sign up. So every 2 will make a group.
Sure.
So you'll work together in the lab, you work together in the together in
Can
the
you
research
finish?
group.
Can you work alone if you want?
You could. You could, yes. It will be more fun usually. I myself, I believe in working in groups, unless it's not useful for you, right? I mean, like, anyways, so yeah, you could do it by yourself, divide yourself in 2, work together, I mean, whatever you like, I'm okay with that. All right, so any questions? No questions? So let's try to. Yes.
For any project, will we have any specific, like if we're going to use any cloud platform, is anything like provided for us, or like Google Cloud or?
GCP,
You could choose
AWS.
anything. I don't dictate anything myself, all right?
Okay.
We'll give you a little bit introduction for it, but you have to learn a lot of things from yourself.
Mhm.
Okay? Yeah.
Database.
Yeah. So usually I don't like to dictate on the students the project they do. First of all, they have a previous knowledge, let them use it, all right? And they could use the rest of their time to learn something new. So, it's, so as I told you, it's, so maybe we already covered a lot of what we're going to talk about in here. So, so another example, we mentioned many examples. I'm not sure if you like this is good.
Yeah.
Okay. All right. So, so one time I invited my friends for a lunch. So you know now the meters, they have the coin, and some of them you could use the card, and you have to search for the spot, and sometimes you come late to the car, you find the ticket. There's always police on the bicycle, coming around and trying to check and all of that. How if we automate all of these? How if, for example, we use an IoT for the whole system, right? That every meter it has a sensor that could report if there's a car parking there, and it can sense when you start parking, when you park there, and sense when you leave, and could charge your credit card directly down to the minute, if you will, or if you wish, okay, without even your intervention. Also, it could, for example, part of the GPS system that you have, if you have a big parking lot, could tell you where is the empty spots before you arrive there. If you are going to park, somewhere to the hospital, for example, or like sometimes here in Thursdays at UB, you cannot find a parking spot. How if we have like each parking spot has a sensor? It does not need to be big like that. It could be something in the ground, okay, that it could detect enough, and each car in the plate, for example, it could, for example, like read the plate, and from the plate could check the account, for example, or it could be any different system, just a system. Give us a system, build us a system better than what we have right now. Many times I take my friends to lunch, I park my car, I put the coins they have. We are always short of coins, right? And we keep going checking out. And the last time we forget to check, we'll come with a $30 ticket, right? Happened to you? Happened to me many times. So how tough is to replace all of these systems with the IoT, camera, auto charge? Okay, this is with the technology, with the available technology now, it's possible, don't you think? All right. One major thing about IoT, description of IoT, they call it technology integrator. So it integrates multiple technologies together to have one useful thing. All right. So when you look IoT, you don't have to reinvent the cloud. You don't have to reinvent the sensing. You don't have to reinvent the communication. There's multiple ways of communication, many sensors or sensing systems, different clouds like you mentioned, or how you integrate the technologies together. It's a technology integrator, as we'll see. All right? So that's me, checking on that, and that's what happens. You detect it, right? All right? So couldn't we build a system to make the life of the people easy?
Of course.
Okay, we could. All right. So there is multiple systems. If you search in the web, this is like one research, I found in the web. So always you could do something about it. So what I need you to think about IoT problem
Solving.
you wish to solve or find a solution for it. All right. Then after that, what you do? Integrate multiple technologies together, and here is the solution. All right. So when it comes to the IoT, in terms of application, where's the talent? The idea.
It's finding the right.
Finding the idea.
That's it. That's the hardest part.
Yeah. All right. If you have the idea, then you could find a solution for it. When it comes to the real research, it's deeper than that. There's a technologies available, but they are not good for IoT.
Sure.
Okay, I'll give you an example. Let's say that we use, HTTP. All right. All right. This is not useful for small sensors because there's a lot of data communicating, a lot of data transmitted and received. When you have a lot of data transmitted and received, that means what?
Need a lot of bandwidth, period.
Power consumption. All the small devices run off battery. All right. So it's a core thing. It's a very important thing that always you must reduce the amount of data transmitted, because every extra bit you send means extra joules. That means shorter lifetime. Right? So there is many, and that's what we're going to go to research. When you deal with IoT, HTTP does not work anymore. You have to look for something else. TCP does not work anymore. We have to look for somebody else. TLS for security does not work anymore. We have to look for something else. That's research, right? So you have to develop certain protocols for this kind of communication. All right, we'll see that, right? All right, so we'll go to always, as usual, we start with Wikipedia. So we need to just, what is the definition? I know you don't like theory, but, or talk, but what is the Internet of Things? So Wikipedia tells you, Internet of Things is a network of physical objects, any physical objects, okay? Or we call them things now. Any physical object, we call them things, embedded with electronics, software, sensors, and connectivity to enable it to achieve a greater value of service by what? Key. IoT. What's the key thing? Communication. What is communication? Exchanging data with whatever. So you exchange the data with the manufacturer, with the operator, with anything. Each thing is uniquely identified. This is another key. Now, any computer connected to the internet has a unique address, whether it's a MAC, IP address, whatever, right? Okay, so it has to be uniquely identified. So this table connected to the internet or this chair, you'll be able to recognize it has an ID. It has an ID that you could, okay? Think about the chairs, like for example, theater, all right? Theater, you need to know if this, for example, what is the most, common chairs used, all right? If you have sensors in these chairs, for example, this is for 20,000 hours, or for 10,000 hours, or minutes, whatever it is. You could monitor it live, all right? Live, okay? You could, do different things for security. You understand? Like you have like the major conference rooms that were people that need security. You monitor things always. So how we can do that? We have to collect data. I have to collect data. All right, from that. So it has to be uniquely identified through its embedded computing system, but it is able to interoperate within the existing internet infrastructure. So another key, this is the third key we're talking about. We are not going to reinvent separate network for Internet of Things. They will be part of what?
Same network.
The current internet infrastructure. They will be part of the current internet infrastructure. We are not going to create a different network for that. So at the Internet of Things conference held in Zurich, and we started to have really conferences named of Internet of Things. Okay, they said the term Internet of Things has come to describe a number of technologies. Remember what I said about IoT is a technology what? Integrator. Never forget this word. It's a number of technologies, right? And research disciplines that enable the internet to reach out into the real world of physical objects. So we're bringing the internet to where? To every object, every physical thing. It's like many years ago, our goal was to bring electricity to every house. All right? Now our goal is to bring what? Internet to every object. All right? What a goal. What a goal, right? Then, in here, for example, in this summit, by embedding short-range mobile transceivers into a wide array of additional gadgets and everyday items, we are enabling new forms of communication between people and things. So Internet of Things is communication between people and things, between things and things. So things and things communicating together, and people and things are communicating together. So these different definitions. Okay, it's a new field, so you'll find different definitions. So Kevin Ashton, who is a founder of the Auto ID Center in MIT, was the first to mention the idea of Internet of Things. Look at this. Again, I read it as a whole. It's a very nice description, but it will. Huh? I'm not sure what's happening. Okay.
You can use the arrows too, I think.
Okay, here. Okay, today, and this, please watch this, because this will open your eyes for your project and all of that. Today, computers and therefore the internet are almost wholly dependent on human beings for information. So for collecting the data, we're depending on what? Is that good or bad? A lot of errors, a lot of mistakes, right? So nearly all of the roughly 50 petabytes of data available on the internet were first captured and created by human. Captured and created by human. Okay, these. By either typing. Typing. How perfect are we in typing, right? You're collecting all these numbers and you enter them. Pressing a record button. Okay? Taking a digital picture or scanning a barcode. Okay. So how much errors, mistakes, by doing it ourselves, right? So the problem is people have limited time, attention, and accuracy, all of which mean they are not very good at capturing data about things in the real world. If we had computers that knew everything there was to know about things using data that gathered without any help from us, we would be able to track and count everything and greatly reduce waste, loss, and cost. We are not good anymore as a human. The machine we have to create the machine that replaces us. So sad. Okay, but that's what it is. Okay? So we would know when things needed replacing, repairing, recalling, and whether they were fresh or past their best. Alright? Think about like you have a fleet of cars, limousines, alright? Usually when there's a problem with the car, when you need the gas, when you need oil replacement, you, the operator, need to know that. Half of all of this fleet is connected to a central cloud that collect the data and give the instructions. Alright? Alright, myself, for example, I have a Honda Accord. I think I have to replace the oil every 5,000. 5,000. My previous car every 3,000. I still replace it every 7,000. So, you know, no. Okay, human is, right? My wife has a Chevy Suburban, I think. I think it's every 7,000 and all of that. Okay, she replaces it every 6,000 because she is my wife. They are more like us, right? People are different, right? So, I mean, I like this definition myself. I like this definition and the goal, right? So we all heard about M2M, machine-to-machine communication, way before Internet of Things. Because at that time we did not care about connecting devices to Internet, rather than connecting them together. So M2M, machine-to-machine, is a broad label that can be used to describe many technologies that enable automated wired and wireless communication between mechanical and electronic devices. All right? So it started from telemetry technology, but you know now we don't hear a lot about M2M. We hear about Internet of Things. So examples. I mean, like many examples or many applications will come, especially in the medical field. All right. So now, for example, you know, you heard about like sick people. They have these devices monitored immediately by the doctors, like a 24/7. Okay, so if somebody like they have a pressure or they have open heart surgery, they have to stay in the hospital for long to monitor them. But if you have these devices, which they are, you know, connected to the cloud, where the doctors can monitor or they could give flags if there is a danger, you know, keep checking your vitals, reporting into the cloud. When your heartbeat or the blood pressure changes, the doctor will be notified. The doctor, when he sees like a critical point, what he will do, will call the ambulance to your house, all right? And the house and the ambulance, because they know that you have serious condition, they don't need to get permission. Maybe they have a key or they have a way to get to your house, okay, to take you right away. I mean, the system gonna change. The whole system gonna change, all right? It's already changing. Before, when somebody does a surgery or something in the hospital, they have to stay for a few days in the hospital. Now it's reduced due to the insurance reasons, of course. But can you imagine what IT what can do for you? All right, you could think about education. I need you to. I did not start thinking about this. How can IoT change the way we teach in colleges? Think 1-2 applications you could do in your project. Okay, think what IoT can do in the health. Think about what IoT can do for Trump wall. Okay, all right. Maybe we could have like electronic wall instead of physical wall. All right. Okay, so think about security in the airports. Okay, think about security in the airports, in the chips, anywhere. Think about IoT anywhere, in your house. Okay, yes?
One question I keep going through my head every time you go through the list of wonderful things that you're talking about.
Yeah.
Are two things. Security and privacy.
Yes.
So they're constantly ringing out in my head.
Yes.
For example, your discussion about changing the oil,
Yes.
7,000 miles versus 3,000 miles.
Yes.
Well, maybe I don't want people to know that I only change my oil every 7,000 miles.
Sure.
But at the same time, I do want my doctor to know that I've had a heart attack and I want to be rushed to the hospital.
Sure.
So certain times I do want privacy, other times I don't want privacy.
Sure.
But in this world that you're talking about, my future car is going to have all this IoT stuff on it.
Yes.
And people are going to know about this stuff whether or not I want them to know.
No. Why whether you want or you don't? You could opt out.
Can you opt out?
Sure. Why not?
Okay.
I mean, like for example, now As I told you, my wife has the Chevy, my Honda does not have that. But OnStar, I think Chevy, they have OnStar, right? For flight. Right, so you could subscribe $5 or $8, and so you could track the car and all of that. I opt out, not because of privacy, because I don't want to pay $8 a month. Right.
No, but he has a point because the age of, things are free, but so many people are selling data. Like, when you sign up for something, you
Sure.
are, signing up for all the information that you hold.
Sure.
And companies are willing to be interested in that.
But we are talking about two different problems.
Sure.
Okay, let me, okay, there is something called my problem, and there is government problem, regulations a problem, constitution a problem, right? Myself, as I'm technologist, okay, I have to make the technology available, right? Whether it's gonna get me regulated by the Congress or by the government or by HIPAA or CHIVA or all of these organizations, that's a different issue, not my problem, right? That's number one. Number two, you're talking about two different things, privacy and security, and they are different, okay? So security is, okay, privacy is something that you have the option to opt out, okay? So for, like the example you mentioned, right? For example, the car thing. Myself, I opt out. I could right now connect my car to Chevy and they send me the messages and all of that, and they could track the car where it is, right? But I opt out myself. That's a privacy. And we all should maintain our privacy. I'm a privacy person, okay? But there is some need for sometimes to give up some of your privacy if you wish. It will not be mandatory. Security is something different. Security, the data must be secure all the time. It's not a privacy. So for example, like the example I mentioned, connecting the doors of your house, okay, to IoT device, so you'll be able to lock, unlock, and all of that. So the data must be secure. All the data, for example, you could have a stream for the camera, right? This has to be secure, no matter what. Okay, so security has to be there all the time. Privacy, you should accept to give up some of your privacy if you need to use these devices. I know. But again, is it your problem, my problem now, in this course?
We just make the technology available.
Available, okay, and and hopefully the stupid people pay us to use our technology, right? All right, that's they're not stupid. I mean, you know what I'm saying.
Yeah.
But part of innovation is making something that is also helpful, but also is not crazy. Because in an ideal world, you could create something so cool, but if it, we also have to think of great innovation, but also what if it fell into the wrong hands or something like that,
Sure, it's exactly like the knife, a very good knife, if it falls, or a gun,
Sure.
or a wall, or whatever, okay. I mean, there is something that you cannot define them precisely. There is something you cannot define them precisely, right? So, and here we're talking about technology, right? So technology, and does not mean that you have a technology available that will be adopted, right? You understand. But I agree with you, privacy and security, and that's how I started my class today. I said without, right? You agree with me, right? You are the most person agree with me on this, right? Without security and privacy, all right? Many of the great technologies we will have, it will not go out there. Okay, so we have to, by the way, we think that we have security and privacy in our networks right now. That's not true. The cyber theft or the cyber crimes every year, it's in trillions of dollars or billions of dollars. I don't know, multiple billions of dollars. All right, right? All right.
Because there's always one factor that no matter how much security you put in place, you can never fully account for all the variables.
Exactly. All right. So, I mean, anyways, I agree with all of you. All respected opinions, but it's not my problem in this class. My problem in the class is to provide technology available for the people after the government approval, after the legal approval. Right? Okay.
It'll be interesting to see how far this ends up going as far as will it be very pervasive throughout every object in your home.
Yeah.
How far that goes would be.
By the way, it's available. I mean, no,
Interesting to find
you
out.
could put all your doors, you could put all lights or your AC on the IoT.
Yeah.
There's a company selling you that. It's available. Just do search and you could install it.
There's a few different, they call it smart homes.
Yes, smart homes.
Yeah.
So
It's
you
available.
can control a lot of
Actually,
it.
actually, this comes, I think, with application for a smart home, right? You know,
Yeah.
the iPhones, they are getting ready for that. By the way, Windows, Microsoft, now you could download IoT Windows. There is a Windows IoT for IoT devices. Okay? Billions of dollars, Cisco and Juniper and all of these are investing every year in IoT. IoT is happening. IoT is growing, well, as we'll see in here. It's not something, it's not a dream thing. Billions of dollars invested already every year by the big companies. Okay? Microsoft IoT, you can download IoT, it's happening, right? So application, so you're talking about industrial automation and monitoring, like tracking, diagnosis, service requests, like I just mentioned example, regulation compliance, like worker safety, environmental monitoring, why is it worker safety again? So, okay, like you know, people who work in far area, deserted area, and all the safety. People who work for IoT. Think about IoT in the mining. People, okay, how that will be, will be okay. Environmental monitoring. Okay, again, people work in the area that the environment is not great. How can you monitor that? When you go to telemedicine, it will be a big thing in telemedicine and healthcare. So you could have the body sensor. I don't know.
Oh, there's a bad.
That's-
Right down, yeah.
I think so. No.
Yeah, but you remember it's
All
not
right.
calibrated.
So for example, now for people who have like all of that, right? So now you swallow a pill with the sensor, with the camera, after 8 hours go out, but while it's going out, it's just sending images of what is seeing inside, okay? So in telemedicine, it will be a big thing. Telemetry, smart meters. Now all of us having that already, right? So like 20 years, 30 years ago, when somebody would like to get the reading for your electric meter or water meter, they knock on the door or they come from the outside, right? Nowadays, I was wondering myself, nobody comes to my house to ask for the numbers, all right? So they drive by. No, they drive by actually. They drive by, and when they drive, they have a device to collect all the readings. Okay, so it seems like that. In the future, because your meter now is not connected to the internet. Okay, still there is some person who drive by, and send the signal will be sent back, and they collect the data. That's how they do it right now. But in the future, you don't need some person to drive by. Now it will be connected to where?
Well, some places do it through PLC.
Or PLC, whatever. Yeah. I don't know.
Is it, what is it, what you're talking about, is that like passive RFID or something like that?
I think so. Yeah. Okay, so asset tracking. This is a big thing. Every item in any store, they will have it. One of the interesting finding is that they found that 75% of the people entering any store, they go to the right first.
It's true.
75.
So many stores are built that way. If you realize it, think of it. But
I'm telling you what I read. Okay, why? But how did they find out? This maybe because it's built like this, but how did they find out? By implementing IoT system. All right. Nowadays, for example, that every shirt, every pants, every tie, everything will have RFID. So they will know. So let's say this is like a pant. This is a bag. It was touched every day 50 times. How is it when it's touched? Because of the motion or whatever, it will be recorded. It was touched. So this is like needed. Keep it. But if you have pants like my pants, that you put them in the store and they did not move or touched for a whole day or a whole week, what does it mean? Send it back. Nobody will buy it, right? So what is this? IoT collecting data. The move is just collecting the data. So this will be the future. Nowadays, most of the items in the stores, what they have? Barcode. Barcode is a paper, you scan it. It's not RFID. RFID, there is passive and active tags, right? So you have passive tags, right? We use RFID for security, not only for in the malls, right? They don't
Well,
use it.
something that's only on items of a certain price.
High price and all that. Okay, so think about fleet management, location, availability, all of these things, many applications. So the paradigm shift in the whole world, okay? Is this 1 hour already?
Yeah.
Huh?
7:15.
Okay, let's finish this slide and we'll have a break. All right, so we're gonna have any time, any place, anything. So we're gonna have any time, any place, anything will be connected to the internet. Why the internet thing is a game changer? It's a game changer for many reasons. The most important thing in my opinion is the last one. It's the technology integrator. It integrates many technologies together to make it like one product. Go back in here, so it's a dynamic control of industry and daily life. Okay, improve resource/utilization ratio. It's better relationship between human and nature. Forming an intellectual entity by integrating a human society and physical systems. Words, all words. Flexible configurations, all words. Okay, universal transport and okay. The most important thing I see it in here, the summary of all of that, in my opinion, and this is the words for this person, is a technology integrator. It's a technology integrator, okay, which makes things to. So IoT penetration in the market, okay, it's increasing. This IoT penetration, all right. So number of connected objects expected to reach 50 billion devices by 2020. 50 billion. It's like 4 times, 5 times more than people. So in 2003, the brown is the number of people. These are the connected devices. This is in 2020. This is the people. Okay, and it's brown for no reason. Okay, and this is our. Okay, and this is the connected device, and again, different column for no reason. 50 billion devices. 50 billion devices. Okay, expected by 2020. All right. Think about it right now. Yourself. How many devices in your house connected to the internet? So myself in my house, I have 5 people. 5 people. Each one of them have a laptop. Each one of them have an iPhone. Okay. Myself, I have 2 desktops in my house. I have 3 laptops. So it's more than double. It's like 3 times already in my house. Okay.
If you got like a Fitbit or an Apple Watch.
Apple Watch and all of that. Okay. So I think myself, this is even the 50 billion is modest number.
Yeah.
It's a modest number. I mean, things are going big, that. I mean, of course, there is part of the whole world didn't have internet, didn't have, you understand, that's why. But, things are changing big time. All right, so IoT penetration is about 180 billion. So in 2016, projection of the internet things, this is slides I created before 2015, that's called projection. Okay. It's like about $180 billion. About 9 trillion IoT will generate merely in annual sales by 2020. 9 trillion. 9 trillion is like 9,000 billions worldwide. Okay, 75%, 3/4 of the companies that are either actively exploring IoT or are already using it, including, Cisco, Juniper, Microsoft, and all of that. 75 of the big companies are using it. The impact will impact every single area of the world. All right, smart devices, for example, in here, these are available already, right? We did not talk about like smart cars, self-driving cars. Okay, so IoT is a core thing. The roads, a core thing in there, right? But smart lights, all these are available already. So we'll stop in here. When we come, we'll talk about the connected support. Let's have a break for 10 minutes, if you don't mind. Thank you so much. All right. So, example of connected. So here, for example, you have distributed control system or PLC connected with a customer gateway. So this is like the customer size that have multiple of these. It will be connected through either cellular or wired or whatever RF connection to the internet. So the connection gonna go to, for example, in here you could have a third-party communication and control center. It will be connected to support and maintenance center. So the data go this way, and if there is an actuation, it's gonna go back. So think about this, for example, like a door. You know, door, okay, detect somebody at the door, so the data gonna go all the way to the cloud that you could access it yourself, that you'll be able to access it, all right? And you could send actuation back, right? To open the door or unlock the door or whatever, right? Remember that we collect the data for two purposes, for real-time applications and for data analysis, right? For data analysis, right?
Is
Of course.
there any other type? A third type?
What is the third type?
I don't know, I'm asking you. Is there any-
Both.
Is there anything else other than those two things?
No, not I know of. So, okay, or both. We could use it both. So it will be for data analysis and also for, real-time application.
Okay.
All right. So, for example, let's talk about like the device to collect information, vital from a patient. So all the day you are collecting data for analysis. But once it's a critical value, you're gonna have actuation, right? Because, like, for example, whatever, inject the patient with some medicine or something, right? All right. So the data flow, how is the data flow? So you have you start from data collection. That's where we start from the bottom, right? Data collection, all right? Data collection, then data transport, and from data transport, data manipulation, then information presentation. You're collecting a lot of data, but the data as a raw data does not have a meaning. So you have to present it, like in terms of average, in terms of the mean, in terms of the mode, in terms of whatever, right? You have to process the data, you're collecting a lot of data. And then after that, you're gonna take an action. Take an action, right? Take an action. So let's take example, like collecting the sugar of a blood from a patient remotely, for example, so that you're collecting the data every 1 hour, so you're checking that sugar of blood, right? Then you transfer the data and you manipulate the data in a certain format, normalize the data, let's say. Okay, then you process the data. You're looking at the average, you're looking at the peak, or looking at the whatever number, and then the action, inject or not inject. Think about the application. So that is a cycle, okay? Starts from the data, okay, and it keeps cycling the communication system and the corporate system. So IoT is all about data. It's all about data. So we start by collecting the data, then process the data. You're collecting a lot of data. It's a lot of data. You have to process it. You have to then you have to display the data. The data has to have a meaning, right? So you have to present it. So then you use the data. Either we use it for real-time action or for analysis. Okay, the real-time action or analysis. And then we have collected the data over a year or 2 years or 3 years for certain projects or certain system. What we do after 1 year, 2 years, 3 years? When we don't need the data anymore, we throw it. Okay? We archive it. We archive it. We work so hard to collect the data, so we have to archive it. So when you talk about archiving the data, what does it mean? Storage. Okay? Serialization. You have to serialize it. You have to store it in a certain way. Right? So it's, and where are you going to serialize it? In the big servers, in the big data, right? So it's like, then operations. So you're going to have maintenance and support, and logistics and fulfillment. All of these are it's all about data. So when you talk about two things I always like to describe IoT. Number one, technology integrator. Number two, it's all about data. Okay, how we collect the data and what we do with the data. That's what it is, right? Now, part of it is communication. You have to communicate the data, right? So you have to study that in your projects, for example. What kind of communication you're gonna use? Wi-Fi, RF, cellular, you know? Is it LAN span, WAN span, MAN span, internet span? What does it do? So there's wireless LANs, wireless WANs, wide area networks, the networking, the RF and antenna design. So when you have a design like a device like that, IoT device, the antenna, you have to design the antenna. You cannot have, for example, a huge antenna. Or you could, if it's for industry, all right? So how are you gonna design the antenna? We're gonna talk about all this. Then you're gonna talk about the data. The data is like the data and how you manipulate the data and how you, okay, so you're gonna have application servers, different application servers in the system you are building, all right? And hardware, digital, analog, power, you have to worry about this. So when you look at the device, this is a hardware, right? Is it collecting digital data or analog data? And what kind of power it uses? What kind of battery? What is the source for the power? You have to worry about all of that. So we'll talk about even in our lectures in the future, the casing, how to case your device, okay? One of the things, you know, one of the older projects that I done when I was doing technology, started doing technology management degree, I stopped, is like creating, that was in 2008 or something. So creating like boots, okay, that could, for the children, that could detect the child within, you know, a diameter around the house. So usually when you ask your children or your children go out to play basketball or play outside the house, you're always worried somebody will talk to them. So you have to watch them, all right? So I said, what if I have like a system that you have in their boots, you know, something, and you have this device at home. So while they are out within, let's say, a quarter of a mile or whatever, like 100 feet or whatever, they're around the house, this device is silent, it's good. But if it starts to go away, so beep, you know, give you like alarm that the kids are moving away from the house or all of that, right? So, so what kind, you know, of communication you're gonna have, what kind of signal, you know, when you have, what kind of sensor you're gonna have, you understand? So there's a lot of things you're gonna think about when you design your system. Event processing, database, and archiving, all of these are needed. What are the components? Many components. Remember that we are talking about a huge system. When you create an IoT system, it's not a small system for your house that you could collect the data and the data stays within the premises of your house. No, you're talking about like a bigger picture, right? All right. Okay. So so you have to know the components: user equipment, M2M devices, gateways, LANs, WANs, surface operations, and delivering evidence a bit here. So that's what it is. You have the side of device and gateway domain, and you have the network domain. We'll talk about it later in different lectures. The network domain, because once the data goes out from your device, it's gonna go to the network domain. It's gonna go to the network domain. So what you have, usually you have the user equipment. Okay, user equipment. Okay, connected to M2M device, and it could be connected to M2M gateway. Then it's connected to the network domain. Or you could have a system without a user device, but it has the M2M device connected to the gateway. Or you could have user equipment connected to the M2M device without gateway in here, and in here without the gateway. All right. So you could have 4 combinations in here, and this is what we call it: machine-to-machine area network. Machine-to-machine area network. Machine-to-machine area network. That's a communication area. Then after that, the data is gonna go to the network domain. To the network domain, it starts with the X network. So, for example, This is IoT device. To access the network, it uses what? Cellular communication, RF communication, right? All right. Or if I'm connected with Wi-Fi, I'm using Wi-Fi access. You know the access Wi-Fi. Okay, communication. Make sense, right? So what are the access networks that are? Many: cellular, wired, fixed, wireless, RF, many others, right? All of these are ways to connect. All right. So let's say that you have an invention, your project. Okay, your project needs to connect to the internet. All right. Most of you, I'm telling you right now, they're gonna use Wi-Fi. Why? Because it's cheapest, right? But you know, in real, you know, for projects, right? But you know, sometimes you need to use cellular communication. So you have a SIM with your device, SIM, and has a number and communicate. That's right. But you know, which one is better, to use Wi-Fi or use the cellular?
Depends.
No.
Depends on the
I mean,
application.
okay, it depends on the application, but definitely the Wi-Fi is cheaper. Okay, but because cell phone, you have to pay like $10 to $20 a month for the T-Mobile or whatever company you're gonna have, right? Okay, but the problem with the Wi-Fi, you cannot get access for Wi-Fi all the time. So what's your application? So the question is, the best way to communicate, okay, it depends on what? What you're doing. What you're doing, all right? It depends on the cost. So for example, if you have this nice application, let's call it application, all right? And it's gonna cost the person, the customer, to buy it $15. But you have to tell him that you have to have subscription to cellular network, $30 a month.
So now I went from 15 to 65.
Okay? 15 is one time. Even if you make it 50 one time, nobody says no. But when you tell them $30 every month or $20 every month, comes an issue. All right? You're having a product. What's the goal? When you have an item, you have a product. What's your item? What's your goal? To sell it. Okay? If you cannot sell it, you know. So in our work in here, and I'm gonna focus on this a lot in the next lectures. What is most important? Not most important. One of the most important issues. Budget, the cost. The cost. So the cheaper now if you have any product less than $10, you'll sell it. I mean, $10 with like 100 million people buy it, better than, you know, $100 product with 1,000 people buys it. Right? So so you have to think about it. Then after that, you're gonna go to the core network, and that's what we call a network management. Then after that, the service management, where you have service character, we will talk about it, and applications. And this is like by ETSI definition architecture for trying to move the slide. All right. All right. All right. So when you look at the user equipment in here that we saw in the previous picture, so what does it include? Okay, application depend on the programmable logic controller. It could have programmable logic control PLC. It could have environmental sensor. It could have machine vibration. I told you like the shirt in the mall, you put like sensor. By vibration, it could know. Okay, depending on the sensor. Fluid levels, like the gas, I told you, the oil example, I told you. Location, and location, that's a big story. Is it the GPS? If it's GPS, maybe it's very expensive. If it's something, you know, what kind of location detection system you're gonna have, control point, smart meter, you know, this is could be anything. Could be a long list, right? Long list. So by looking at the user equipment by itself is a whole science. If you look at the sensors, so for example, inventing the sensors. So the sensors measure temperature, pressure, height, you know, position, all of that. So, and each one of them, each function of them could have like 20, 30, 100 different kinds. I mean, you could have like some of them like to measure temperature, but they're so accurate sensor. But to buy one sensor is like $100. And some of them like not so accurate. Some of them could live for so many years. Some of them, the lifespan is long. You understand? So a lot of research, a lot of invention, a lot of work needs to be done in this arena. You know, sensors and all of that, right? What I'm trying to tell you, that every line you see in the PowerPoint presentation, you have a room to be part of it, to be a scholar, to be a scientist. All right? That's what is science. What is science? Science and scholarship is about contribution. And you make this contribution available for everybody. Everybody will learn from it and give it to somebody else. Give the patent to somebody else and continue. You agree? All right? Let me know if you get bored, okay? All right. So I'll give you a quiz. All right. So then the second part is like the end-to-end device. So that could include hardware and software. Hardware and software. So hardware, like sensors, equipment interfaces, cellular, short-range wireless modem, RF electronics, antenna. Antenna is a big issue. A big issue. We'll talk about it later. Okay, power subsystem. Of course, any device has to have a power. How you're feeding it, right? And packaging. This packaging, it's one of the most important topics. We're going to talk about it in the whole class. How you package your product. All right? Think about what is this device? Remote pointer, right? So if I package it with something like that, how it will be? Okay? All right? So package it. How you package your product is a very important. Software, network interface with a firewall, modem, application, API, device management control, and the applications and all of that. So we're going to talk in details about this stuff later, and here just giving you an overview, by the way. So the end-to-end device, okay, so it runs applications and service capabilities, and we'll talk about this. So part of the things, for example, registration, like your phone. When you buy a new phone, right? You put the SIM card. What is the first thing it has to do?
Register on the network.
Registration. So you have a device, it's not a cell phone, it's this, all right? And you have a SIM card with it. What do you have to do? Registration. How are you going to do the registration? It's part of your job. Okay, it's part of your registration. Authentication. How is authenticated to connect? What is security? Authentication. Authorization. Authorization, what it is authorized to do. Okay, authentication, is it authentic? And by the way, when you talk about authentication, for those talk security, the authentication has to be both ways. I'll give you an example with both ways of authentication, right? So for example, you have an account with People's Bank, right? So when you put your username and your password, who has to authenticate you? The bank, right? But you also has to authenticate it's a correct page, because somebody could send you a link. Oh, this is your People's Bank account, but it's a fake one. So as a user, what you have to do? Authenticate that you are entering your data in authentic web page. So authentication, always remember this. If you're gonna learn anything from me today, authentication has to be mutual, both ways. Authorization, okay, management, okay, provisioning with the network limit. So how you provision, right? So for example, anyways, we'll talk about in details. All right. So end-to-end device in here. So you have this is the device. This is the device. Okay. This is end-to-end device. So what part of it will have sensors? It will have legacy communication port like serial port, for example. It could have WLAN ports, Wi-Fi, whatever. Or okay, it could have other. It will have a brain. It will have a processor, right? Okay, control processor and cellular modem communication, and will have what? Power subsystem. Battery could be. How to get the data. This is the device in here. Okay? It has all of these. Yourself, you're building this. I'm buying this. You designing this, you building this, you're putting all of these boxes in your device. So you have to decide what kind of power subsystem you're gonna have. You're gonna decide you're gonna have a cellular or Wi-Fi or what kind of communication. You have a CPU, right? CPU, the brain, where you put the program, where it works. Are you using Uno, or using the Raspberry Pi, or using your embedded system, your own design FPGA, or what? You're designing this, you're selling it. You are the person making millions of dollars later, to the point we cannot talk to you anymore, right? Because you have money, right? All right, so we're gonna talk about all of these later. So this is, for example, the device, the gateway, the network. So we're gonna talk about the surface capabilities. What are the surface capabilities of the device? So in terms of application and enablement, generate communication, security, okay, compensation broker. I mean, like you have a device, and the device is working through T-Mobile or a network, right? The T-Mobile at this time what they call broker, because they charge you for each communication. So how do you configure all of that, right? Okay, interworking proxy, reachability, whatever, communication selection, remote entity management, transaction management, operator exposure. All of these are surfaces. We're talking about surfaces. We don't talk about software now. We don't talk about hardware. Surfaces that your device, that you are inventing, that you are making, has to deal with. So you have to have some knowledge about all of these. If you are not, if you don't have a broker, then what's the value of this will be, for example, null. That's fine, it's not there. But it's not all of them would be null. All right, so protocol stack, that will come to research, as I told you. So for example, if you're gonna go, for example, regular web, it will use a lot ample bit rate. The devices has very low bit rate, has to be very low bit rate. Okay, ample power. Why? Why regular web has ample? Because you're connected to the power. Do you wear a mobile? But this is connected to where? The battery. So you have to, the power is constrained. Large processing power. Why? Because it has a 8-core CPU. This is it has like a very small brain. Okay, so it has a processing. So that's why we cannot use, for example, a very strong security protocols. Why? Because we have a small processor. It's gonna take forever to calculate one key, for example. Right? So large data flow, and here you have a small data flow. Okay, near communication. Okay, connectivity. This is intermittent connectivity. The connection not available all the time. Right? Look at the protocols, and we're gonna give you a whole lectures about. So for security, we'll use TLS, transport layer security. This will use something DTLS. We'll show you the difference later. IP4, you know what's IP4? IP4 does not work for IP. We use what? 6LoWPAN. We'll explain to you what 6LoWPAN later. HTTP, everybody knows HTTP. But it's so slow. I mean, just to send one page, a lot of data communicate. We cannot work with this. We don't have the power, we don't have the capacity, it will be very slow. So we developed something called co-op. We'll explain it later. OSPF for routing, Rebel. I mean, a whole lecture. We're going to talk a whole lecture about this, a whole lecture about that. That's in terms of the research and all that. So you know it all right now. I'm sure, I hope by now you know what are these. So if you took security, network security, TLS, there's a protocol for security, right? Okay. IP4, everybody knows IP4. If you don't, we're going to talk about it, and IP6, right? HTTP, hypertext transfer protocol, right? That's for web. Okay, OSPF is a routing protocol. Anybody that networks should know. So here is a comparison between TLS and DTLS. Okay, so this is transport layer security. This is data, and you know what the difference between datagram and like for example TCP and UDP.
Yes.
Anybody knows?
Yes.
TCP Anybody does not know? I'll explain it if you don't know. Huh?
Repeat the question, I'm sorry.
TCP and UDP.
Can you go over it?
In communication, in transport layer, there's two protocols. There is TCP and UDP. All right? So TCP, this is a connection-oriented. We call it connection-oriented communication. This we call it connections-less. All right? So this is reliable. This is reliable. This is not reliable. Okay? This is similar to the phone system. Phone system. It's similar to the mail system. All right. All right. So this is higher security than this. What's connection oriented is you have to have a connection first, like the phone system. So let's say when I call somebody, what I have to do? I have to dial. Okay. Then the person has to respond. Then we transmit the data back and forth. So it's a connection oriented, right? It's like a phone system. The UDP is connectionless, like sending in a mail. So when I send you a mail, do I have to tell you I'm sending you a mail? No, do I have to connect with you? I just send it. That's why we call it connectionless. All right. Which one is more reliable?
TCP.
Huh? TCP. Why? Because it's a connection oriented. So I'll give you an example. If next week there is no class, so if I call you, I tell you there's no class, is it more reliable or is it more reliable when I send you a mail?
Phone call.
Phone call. Why? Because I have to dial you. I have to make sure that you are on the other line, and then I send you the data, the information. No class. But if I write a mail for you, you could receive it, you could not receive it, right?
Well, I
You
think,
could open it, you could not open it.
I think it's liable because it makes sure that all the packages are received.
In this one, in the
Yeah,
TCP.
TCP.
Exactly, okay? So the same thing in here, all right? Transport layer is more secure, but it's so sluggish. Okay, so sluggish, slow. In IoT, we don't use, we sacrifice security for speed. We use datagram transport, right? So this is TCP based, but in IoT it's UDP based, which is unreliable transport, all right? This is rely on the MAC sequence. This add explicit sequence to the data. Anyways, so DLT is less secure, but it's more fast. That's why we use it in IoT, all right? We'll talk about it later. Also another example, 6LoWPAN, okay? So in IoT, okay, we have to have a small packet size because we don't want to transmit a lot of data. Low data rates, the connection will be star or mesh topology, and we need to aim for low power, low processing power, large device count, because we're going to have like thousands of the small devices, all right? And we could have ad hoc and mobile communication and a reliable communication. For that, we have developed 6LoWPAN protocol, which we're going to talk about it later in a different lecture.
So
Yes,
6LoWPAN is just a name or is it protocol?
it's a protocol.
It's a protocol?
Yes, the whole protocol. So same thing, HTTP is sluggish. It's a big protocol that we use every day, but it's not good for small devices. We're going to use something called call. Okay, and we're going to explain it in a different lecture. All right. Ripple is for low power and loss networks. All right, and also it's a routing protocol. We're going to explain it in one lecture. We're going to come to it again. All right. So now, for a standard, is there a standard? I mean, there's no fixed standard. People are trying to make standards for that. So one of the standards is one M2M org. You could take a look at the page, and there's the major players from Japan, China, Europe, etc. You could take a look at that. All right.
I have a question.
Yes.
Early on in the lecture, you mentioned that aviation or space systems was the genesis of the M2M, which is the precursor to IoT.
Yes.
But yet during most of this lecture, you keep mentioning M2M instead of IoT. But if it's a precursor to IoT, why are we still talking about it?
I don't know. It's a good question. It's a good question. Maybe because the resources I was referring, I got the information was about M2M.
Okay.
But nowadays for us it's like synonyms.
They're synonymous?
Yes.
Okay.
Okay, so it's like M2M or Internet of Things. Okay.
Okay.
So, okay.
MTM is a part of the IoT.
Huh?
It's the fact of connection of machine to machine. That's what's IoT for.
Sure. I mean,
MTM is like a part of IoT. IoT is the big picture and IoT is one.
sure. I mean, like M2M is like machine-to-machine connection, whether involves internet or without, or does not involve internet. So in that sense, it's more general, right? But IoT is also device-to-device, but involves internet. So which one is general than the other? Depends on the angle you look at it. But you know, for you, for us, M2M or IoT, same thing. Okay. And actually, there is some M2P, machine to people, and people to M2M. Anyways. So it's a, all right. So system level features that Internet of Things needs to support: device, heterogeneity. So are the devices heterogeneous or homogeneous? Are the same or different? So we expect that you're gonna have in the Internet of Things that heterogeneous devices. How you connect them? Scalability. So, and you equals the exchange through proximity wireless technologies, energy optimized solutions. All of these are kind of research topics, you know, that you have to deal with, especially the last one, energy optimized solutions, right? So, I mean that's what big search are going on even in the cell phones. How can I make the cell phones last longer? Okay, the problem is it's infinite work. Why? Because you consume more power when you transmit more data, right? When you have a brighter screen, nicer screen, right? Right, that's what they do. But every iPhone comes, it has like brighter screen, nicer screen. It sends and transmits more faster, you know, photos and videos, and that will reduce the battery. What I'm trying to say, if we take the battery of this phone and we put it in the old cell phones, you know, the flip cell phones, so that cell phone maybe will last for 2 weeks. So they are improving in the batteries, but also the service they're giving to us is much more. It consumes more battery. So we're consuming more battery, but they're giving us better battery. So it's like, you know, fighting in, you know, against each other. So, okay. So all of these are issues need to be, okay. This is very important. So stages to bring IoT service to the market. It starts with a business application definition. That's what you're going to do in your project. This is a very important slide for you. Then trial surface. So you're going to iterate in here until you have like the application that you think it's viable, right? Then after that, you're going to have the implementation. So a lot of time you're going to spend in here. Then implementation strategy, design, development, and functional testing. Testing is a very important. It's a big thing, testing, right? Then after regulation and certification testing. This is also a big issue. So when you have a system that uses a wireless system, it has to be regulated by the government.